Good morning, everybody. Welcome. Croeso cynnes I chi gyd. Croeso. Welcome to Beach Lab online. First time we've ever tried this, and hope you're going to be with us for a couple of hours and enjoying what we've got on show for you. So my name's Stephen Fern. I'm a member of the Aberystwyth Robotics Club, and what we do is we bring and we give the opportunity to children to build their own robots, and with undergraduates and members of the staff, we are the Aberystwyth Robotics Club based in Aberystwyth University. So every year we highlight or showcase our robots at this iconic building behind us. This is Aberystwyth Bandstand on the promenade, but unfortunately, due to circumstances beyond our control, we're having to do it in a different format this year. Beach Lab still runs, but we're going to be doing it online instead. So we've got a huge format of different things to show for you today. Everything from sort of hobby and pet robots through to sailing robots, through to fighting robots. And we've got some really nice treats in for you for today. I hope you enjoy. It. There's a couple of things as well. If you're watching us on YouTube, it's great to see you. And we've actually got a live chat as well. And I can see that some of the people are already starting to sort of come through to us. So good morning to Charlotte and Rob. Rob's up in Newtown, and it's great to see you. There's a couple of our ex-club members there who have been significant to us in the past, so it's lovely to see you guys on. So we got the live chat coming through to us as well. We will be running today approximately 17 presentations across the board, which is quite exciting. And so we will be going across live via the wonderful technology that we have to the individuals, so that we can ask questions as well. So if there are any questions about the particular robot that you want to know about, then stick it on through the live chat. So lovely to see Andrew's on board as well. Morning Patricia, morning Helen, and it's great to see you all in there. So before we really carry on, I just need to say a big, huge thank you basically to all our Robotics Club staff and supporters. Huge thank you to Thomas Fern, who's sitting next to me here at the moment, who's driving literally all this technology. I'm quite lucky. All I got to do is sit here and talk. Big, huge thanks to everybody else. Patricia, Tally, Helen, Fred, Colin, Andrew Forster, Rowan, Andrew and Malley, and everybody else that's really made the effort to sort of pull this little lot together. I'm sorry if I've forgotten anybody, but I hope I haven't. So one of the things that we've got to go through is a program of events that is going on today. And so we're going to be going to show you what is happening as far as the first section is concerned. Nope, hang on. Quick change in tack. You'll have to bear with me today, okay? This is the first time we've tried it, so it's a little bit of testing the water a little bit. One of the sad things we have to announce is a very good friend and a very dear friend and colleague of ours has passed away, unfortunately, Martin Nelms. Martin was an incredible gentleman, very happy individual, and he unfortunately lost his battle against the dreaded disease. And so as a tribute, I just want to read out a couple of things rather than me trying to ad lib. It's a lot better. So this is something that's coming from a lot of his colleagues. So Martin travelled around the UK to take his knowledge to schools, festivals and the wider public. And a glowing testimony that we've all received from the teachers that he was with. We know that children loved learning in his lessons, and we know he enjoyed teaching it. He encouraged diversity in all aspects and was a natural entertainer, and had the most creative of ideas to spread the message about the work that was being undertaken at the university. Colleagues working with Martin have commented that Martin was one of the happiest people I have ever met. Martin was a valued colleague and a friend to many of us within the faculty, and fondly remembered by everybody. Martin was a natural and experienced teacher, equally at ease, introducing young children to their first experience of science and experiments, and guiding our children into the university life, and helping academic colleagues to learn new ways of sharing their knowledge to a wider audience. So here's our tribute to Martin. A very dear friend of ours who unfortunately passed away recently. So, moving on, folks. We've got a lot of things that we've got to try and crack on with today. So we really need to sort of have a look at the schedule of things that's going to be happening. All of a sudden, my background has moved ever so slightly, so we should at some stage have a view of what is going to be sort of happening behind us. We've got 3 presentations to start off with an audience with the Daleks, and we've also got another session where we've got how the TV robots work, and we've got one of our club members. Oh, hang on, let me move across a little bit so you can see this. This is better. That's more like it. Thank you, Thomas. How do our favourite TV robots work? We've got a presentation by one of our club members, Rowan, who's going to be talking about Red Dwarf and Scudder. And we've also got, I'm certainly hoping that we should have something regarding the programme for this week as well. So this week, there's a lot, because it's Robotics Week. It's just not Beach Lab. This is happening UK wide, and so there's a lot of things that are going to be happening, which is going to be happening through the university and the members of the club. And so on Monday evening we have an evening of robotics, and this is a bio-inspired robotics evening, and the talks will be talking about the latest research in bio-inspired robotics at Aberystwyth University. Keynote speakers at the moment is Dr. Patricia Shaw and Dr. Myra Wilson. And there'll be a little bit more about what they're doing a little bit later. Wednesday, we've got 3D CAD design with Tally. And so all of the links and bits and pieces can be obviously found here. Thursday, we've got an electronics workshop. So a lot of people want to know and do a little bit about robots and how do we build them, but the basics is you need the electronics to go inside them and how to run them. Friday, we've got a bit of a fun one. We've got a robotics pub quiz. That should be a bit of fun. And then in the meantime, and it's available all week if anybody fancies doing it, we've got robotic crafts. And if you actually go onto this link, this will give you an idea of what there is and what there is available, okay? And a lot of the information can be picked up through robotics.club as well. Okay, so without further ado, oh, hang on, I need to move over a little bit so you can still see me. Without further ado, we've got our first presentation. Now, she's quite an unusual robot, this one, because she's got quite a personality. And I'm sure many of you have seen her around. She's certainly been visiting Beach Lab over the last few years. Quite an unusual character. What we'll do is, I think we'll go across to Dalek Doris and see what she's got to say for herself. So, ladies and gentlemen, international superstar and Dalek around town, let's introduce you to Dalek Doris. And today at Beach Lab Online, we're going to be asking Dalek Doris a couple of questions.
Yes?
So, Dalek Doris, where do you go and what do you do for fun?
I like to go to the roller skate park and skate all day. It's my favourite hobby, other than exterminating children.
Okay then, Doris. Is there a Beach Lab talk that you're looking forward to?
Indeed there is. I'm most looking forward to Ian and Simon's talk about Razor.
So, Dalek Doris, how do you eat? And how do you like your steak?
If you're talking about human steaks, I like mine medium rare.
And here's a question from Patricia. What's your favourite drink?
I do like a pint of Carlsberg, but I need to stay professional. We are always on duty.
Okay, Dalek Doris.
Yes?
What is your favourite music? And can you show us some of your dance moves?
Indeed I can.
Okay, Dalek Doris, thank you for that.
You're welcome.
Tell me, who is your favourite doctor and why?
The dead one, because he's dead. Ha 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 ha.
Which aliens from Doctor Who would you least want to come up against, other than the Doctor and the Time Lords?
Any monsters which have water. Daleks do not like water.
And here's a question from Tally. How are you assimilating to life on Earth?
It's difficult, but it's much better than working for Davros. I've started my own cupcake making company. I've already got the accessories.
And so how many different languages can the Daleks speak?
Daleks only need one language, and it is universally recognised. Exterminate!
To exterminate. Okay, Dalek Doris.
Yes?
What is your favourite karaoke song?
Well, this is a bit embarrassing. My favourite karaoke song is Happiness, Happiness, the greatest gift that I possess. I thank Davros that I've been blessed with more of my share of happiness. What?
Okay, Dalek Doris. How do you deal when you get an itch?
Not very well. I guess if you scratch my back, I'll scratch yours. What are these tools for?
Okay, Dalek Doris, in 2020, Would you consider living on Earth?
Well, I haven't got a choice. We can only travel 5 miles.
Thank you, Dalek Doris, for answering all our questions.
You're welcome.
Is there anything else you'd like to add?
Enjoy Beach Lab, or you will be exterminated. Exterminate!
I'm not programmed to bark, Master.
Hello, and welcome to Dalek Doris and the Droids. I'm sure you all recognise this little character. This is K9 from the Doctor Who series, and of course the Sarah Jane Adventures. A very, very popular little droid, and he's been involved in lots of different shows and exhibitions over the years, starting back in 2009, when my young son at the time wanted a little robot that he could drive around. So this was the first of 5 of the different robots which I've made, and he goes out and exhibits at different exhibitions and science fairs all over the UK. One of the most popular ones that we were involved in was at the Fleet Air Arm in Yeovil, and it was a thing called Invasion of the Daleks, and this one was there to support the Daleks, and we met many of the members from the Doctor Who film and series. As you can see from the videos that have been up previously, he does move around, he interacts with people, he talks, and we also have on the side of him as well, apart from the flashing lights on his ears, we also, thank you K9, you've got to turn around, he also has the display screen on the side. Like the rest of the robots that we have, he does work on wheelchair motors, and he's fully radio controlled, so we can actually drive this young chap around the place. K9 has been very, very popular with the Comic-Cons and conventions that we've attended, and we've actually been there to support John Leeson, who is in fact the voice of K9 in Doctor Who. He's proved to be so popular that we were very, very fortunate that we actually went to Windsor at one stage, and we worked with Tom Baker, and we were very, very lucky in the respect. So if you want to come and have a quick look at K9's bum, you will actually see that because he's so popular, he has in fact been signed by John Leeson, who is the voice of K9 in Doctor Who and Sarah Jane Adventures. Bob Baker, who is the original designer creator of K9. We've got Matt Irvin, who owns the current K9, and we're very fortunate to work with him at the Leicester Space Centre. And our K9 is a direct replica of what he has got. But the most important one for us was Tom Baker. As you can see, we've got his autograph at the bottom end here. So yes, K9 is Tom Baker's dog, really, going back to his time on the Doctor Who thing. He's fully interactive, works off wheelchair motors, he's got all the push buttons and lights, he's got a display on the side, and his lights and his ears rotate as well. A very, very popular robot that really started the journey for us with the entertainment robots. And over the next few episodes, you'll be able to see our other robots that have been designed as well. Welcome to the next instalment of the entertainment robots. This is Dizzy the Droid, a steampunk R2 unit, which has been made for about 2 or 3 years now and is one of the most popular of the steampunk robots on the circuit with me. Based on an R2 unit, the chassis is identical to an R2, but with a slight difference that in this case we actually have the drive systems in the wheels, and they are two 24-volt motors which allow the robot to rotate and run around. He is interactive. He's obviously got the sounds which you could just hear, and he also has the chimney to make it sound as if it is like a steam engine or a steam train as it's running around. The idea or the concept is originally from Mark Enright, Podpad Studios. Big hats off to him as a very, very talented designer. But this one is actually mine. I built this one from scratch. And I've built it from bits, recycled bits. The whole of this robot is recycled, from the dome down to the wheelchair motors. And all the bits and pieces are all scrap items which have been recycled and repurposed to make this rather engaging robot. If you have a look at the front end here, you'll see right in the middle is the heart of the droid. This is what gives the droid its personality. These are actually old radio valves and transmitter valves, and right in the bottom of them are small multicolored LED, and so this lights up the whole of the valve, and it gives it makes it look as if it's the heart and it's working and operating from there. It is completely electronically controlled, and so there is quite a complicated wiring system to ensure that this robot does work comfortably and reliably within a public environment. As you can see in the back, we use our standard motor controllers, which are the saber-tooth motor controllers, and a standard radio controlled system operating on 2.4 gigahertz. We prefer to leave all the control systems exposed like this so that people can see what the robot actually looks like. And above, right in this point here, we actually have the sound system, which allows the robot to sound as if it actually is a steam-powered machine. As you see at the back, we've also got Yoda sitting quite comfortably here, keeping himself warm around the chimney. As you can see, the chimney is smoking. But this smoke, it's not dangerous, it's actually water vapour. And it's done by using the small pond misters inside the bottom of the chimney. And to get this working, all we do is we top it up with water, and this will quite happily run and is safe to use in a public environment. The dome is new for 2020, and it is R2's recycled dome, and we've got the radio control system that will allow us to be able to rotate Dizzy's dome. The control system works on standard radio control system, 2.4 gig, very, very reliable, and this allows you to operate and move a robot around under complete control, and so that many other robots can be running at the same time and in close proximity without any interference from other transmitters. The nice thing about these is that there is automatic fail-safes, so that if at any stage there is any interference or we lose control from the transmitter, the robot does automatically go into shutdown procedure. This stems very much from the rules and regulations that we used to have when we were doing the fighting robots in the days of Robot Wars. The dome from the R2 unit is the new polished dome. This was from my original R2 unit, which you'll be able to see in one of the other units, and from this one it has obviously been colour changed and made a lot more steampunk style with a lot of the dome rotation, the panels actually being on the outside of the dome rather than being integral and actually part of it. One of the good things about this robot is that it does do a lot of charitable work. We do take it out to a lot of charity events, and we do raise money for juvenile diabetes. So, does it have a top speed? Well, in public environments we tend not to allow it to go too fast because there are other people around, and we also have to be able to operate it in a public environment and in a controlled environment, so that the whole thing is safe, and so that a lot of children get rather excited when they do get around it. It does quite have each robot does have its own personality, which makes it quite exciting, and we're looking forward to taking him out later on in the year. So that's Dizzy the robot, and then you'll be able to see the other parts of the other types of entertainment robots that we've got shortly. Thank you. Hi, and welcome to another installation of Dalek Doris and the Droids. And here, as you can see, is a well-known and iconic robot, R2-D2, from the Star Wars movies. In fact, all of the Star Wars movies is featured in. This one is quite a well-known robot. 2,500 pieces installed in this robot, and over 2 years to actually make him. So it's quite a lot of work gone into this one. He's done quite a few Comic-Cons. He's a very well-travelled robot. In fact, he was involved with the UK government and Indian government at the trade exhibition in Delhi a couple of years ago. So this young man has travelled quite a bit, and it works very similar to the rest of our robots on a set of wheelchair motors, recycled obviously, and we're concentrating on the Sabertooth motor controller system once again, with a standard 2.4 gigahertz 6-channel mixer and receiver. His head obviously rotates, and if you have a look inside you can get a chance to see some of the inner workings of R2. Starts off with the kill switch for the 24 and 12 volt sections. He's got the switching radio receiver for switching the dome lights and for switching the feet lights, as well as coordinating the sound. The sound system comes through the standard programmable power amplifier with the usual R2 bleeps, pops and sounds. And if you look at the very top here, you'll be able to see that we've got the standard Sabertooth controller with the voltage level indicators, so we get a constant value of how much juice there actually is in R2 as he's running around. Another very reliable robot. He will quite happily run around for a couple of hours, and yeah, really good, reliable little thing. Once again, he's worked with quite a few of the actors from the Star Wars films. We're very lucky. He's worked with David Prowse, and we're very pleased to have Darth Vader sign our R2 unit. And if you actually come around the other side, one of the things we're really proud of, and we had an audience with Kenny Baker, who actually played R2 in the first series, the first films of Star Wars. And yeah, he was well chuffed with the way that the whole of this little robot was represented. And of course, Kieran Shah, who plays the stunt double for Kenny Baker in the Star Wars films. So there's our little R2 unit. This was the third in the series of robots that we've built. K9 started it all off for us. Then we moved on to Doris, who we're going to be having an audience with a little bit later on. And then we moved on to BB-8. And so there's a little story coming from him shortly as well. Hello and welcome back to the latest of the series of the robots that I've built with Dalek, Doris and the droids. Here's our latest addition to the family. This is obviously you recognise from the Star Wars films. This is BB-8. This one, unlike the rest of these, does not move around. He is actually a static droid, but there's good representation of what the droid looks like from the Star Wars movie. Quite an unusual head on this one. In this case we've got casters with a motor system that allows the head to actually rotate on the body, and it has the usual sort of sound effects that people will be able to hear as it goes quite close to it. The dome is quite unique in the respect that it's actually 3D printed. This is one of the first things that we've used as far as the technology is concerned, and it's worked out incredibly well. It's built into different sections. The whole lot has been glued together, and it's been actually seamed so that you can't actually tell that it's been made in different parts. Obviously the BB-8 colours of the bright orange, and this one has been also been given a bit of battle damage to make it look as if it's been through some really hard times out in the desert. The idea of this one is to make it a little bit more interactive so that he can stay as a static in the exhibitions. The intention is not to have this as a rolling robot, purely because of the time and effort etc. that goes into running just one of these robots. Incredibly labour intensive with all the gimbals and the motor drives within the inside of the robot. The body, very strong. It is actually a fiberglass sphere. It does split into two, so we can get to the inside and produce electronics and put electronics inside it. But in this case we do have screen transfers on the outside of the robot to give it its authentication. So there's the two from our Star Wars films. Hope you like it. This one hasn't been signed yet, but I'm sure at some stage he'll be taking part in some of the Star Wars Comic-Cons, and I'm sure we'll end up meeting some of the artists involved with it.
Are we on?
Yep.
Okay, well, thank you ever so much for that. Me. Hope you enjoyed that. Gives you a bit of a background on the ideas that I've been involved with, or with Thomas, over the last 10, 15 years or so, building different droids. It hasn't stopped there, because there are a couple of other things going on as well. So we do have live questions coming in on the YouTube chat box. And so if you have any questions about anything that the presenters are doing, then please do feel free to message us, because we will try and pick up your questions and ask it to the presenters. We have had one from Little Miss Tally. So what is your next project? Well, there's two on the go. I finished one just with the university recently, which is a full-scale replica of ExoMars, and we're going to have a presentation from Helen about the ExoMars project a little bit later on. But personally, I've built a time machine, so that's ongoing. It's in bits, and some of the spraying and other bits and pieces have been done, and we'll see how it goes with that. And we're looking at doing a replica of another rather well-known fighting robot.
But that's on the back burner at the moment. We've had a question from Riley on the YouTube question side of things. Do you reckon you'll eventually make your own moving BB-8 droid? I'd love to, but because I've got so many robots, taking them all out, and then you'll have one static for a short while, and then you'll take another one out for a short while and demonstrate them all. The complexities of building a BB-8 is quite difficult. I can do it, 3D printing stuff, and the BB-8 forum on your Facebook is just fabulous. But I've made it now, and believe it or not, that had to be possibly the quickest robot I've ever built. It took me 3 months from seeing the film to actually doing its first show. So that was out there quite fast. So I'm going to... so no, BB-8 will not be rolling. So I've had another question from Maya, from Fiona, I think it is. Time machine. Bring me back a dinosaur. That'd be fun, wouldn't it? Yeah. Can see a dinosaur stomping through Aberystwyth. Okay. Is it and another one from Rob. Is it going to be a DeLorean or a TARDIS? I think you may have to wait until you see the grand opening, which will be at possibly one of the steampunk fairs in the future. But I dare say you'll see me bombing up and down Aberystwyth Promenade in it as well. So that's enough about me and the entertainment robots. Hope you enjoyed that. We do have lots of things going on, so I'm going to be quiet now and move on to our next presenter. And this is Rowan. Now, Rowan is one of our Aberystwyth Robotics Club members, and she's a student in Penglais School, and she's in the advanced section of our robotics club. And Rowan has got extensive experience in designing, building, soldering, 3D printing her robot over different robots and different projects over the last few years. And she's now actually made 2 of her little robots. So what we're going to do now is we're going to go over to Rowan, see her video, and then we're going to come back and then we're going to do some live Q&A sessions with Rowan. So if there's any questions you want to ask, stick it onto the YouTube channel, and then we'll pick it up in a little bit later. So without further ado, it's across to Rowan. Thank you.
Hi, my name's Rowan King and I'm part of the Aberystwyth Robotics Club. Have you ever watched the TV series Red Dwarf? If you have, you may have seen a small service robot roaming the corridors of the giant city of Aspasia. Usually they are blue in colour, but were originally built out of a bin lid and a table lamp. These are called scutters. Today I'm going to be talking about building my own scutters. I have been watching Red Dwarf with my family for a long time, and when I got the opportunity to make my own robot in the robotics club, I decided to make my own scutter. I knew I would have to do a lot of programming, electronics and 3D designing, which were all skills I wanted to develop, and it sounded like a lot of fun and a challenge. It began by 2 magician chassis put together with motors on the sides. Eventually, I added sonars so I can let it drive around on its own without bumping into anything. Hopefully. I used Arduino to control the scutter, and when it sees an object, it will reverse back and turn around and go in a different direction. It does have problems driving on some floors, possibly because of the weight. Then, using Design Spark 3D Designs program, I designed the shell for the body, a dome for the base of the neck, and the head. This was later printed, painted blue and glued together. The glue took a very long time to set and spent a couple of months as a gooey mess, but it's all cleaned up now. I also 3D printed 6 supports to screw onto the chassis to hold the shell in place. 2 parts of the head were printed separately as we needed to make sure I could still access the battery pack, Arduino Nano, LEDs and a speaker. We created a secret compartment to keep the circuit board in, which was designed and cut using a computer program called Eagle. To make sure that we can access the not-so-secret compartment, but still close the gap between the 2 parts, we used magnets. The LEDs are the eyes, and a small speaker plays a tune from one of the episodes, which is a reference to Red Dwarf, and the Red Dwarf theme tune. For the finger mouth bits, we used high density foam to get the shape of a finger, and as the neck I used an old table lamp that we found. A servo was installed in the dome which will allow the neck to turn 90 degrees both ways, but unfortunately we haven't quite got to that yet. I plan to get the servo working at some point, although this will be difficult to do while keeping the neck and the head balanced.
You don't know what you're missing. I'm sure. Yeah. You'll never look back at the stroking your robot.
Recently I've started a second scatter. However, this scatter is not blue. In one of the episodes of Red Dwarf, the characters go to a parallel dimension where girls are boys and boys are girls, and also cats are dogs and dogs are cats. Anyway, there are pink scatters, and by the end of the episode there are a bunch of baby pink and blue scatters. I've decided to make my second scatter not only a pink scatter, but a baby pink scatter. This one's called Pinky and the other one's called Perky, which is another reference to Red Dwarf, which is another reference to a children's TV show. I've used another chassis, but instead of motors, there are servos, and instead of sonars, I've decided that I want a bit more control, and we're using a remote controller, which means that I can make it seem more interactive. The controller connects to an Arduino through Bluetooth. I 3D designed and printed the parts again, and then it was sprayed bright pink. It's much pinker than I expected, but the brighter the better. The scatter is a little bit chubby, but I think it makes it look more like a baby. The first attempt at printing the body ended up like spaghetti, and the head was a bit too small first time round, and so it wasn't proportional, so I did have to reprint it. Again, for the finger parts of the mouth, I used high density foam left over from the big scatter. This scatter also has a disco setting. I used a NeoPixel connected to an Arduino Nano to light up the head with lots of different colours. I haven't quite got the whole thing working yet because the controls aren't quite working properly, but it's getting there, and I will need to make supports to hold the shell over the chassis to keep it balanced. Also, at the moment, it only works when it's connected to a power plug, and the disco setting only works when it's connected to a laptop. It's nearly there. To get to this point, I've developed a lot of skills, including 3D designing, Arduino, programming, practical skills, for example, drilling, cutting, soldering, using Eagle to print circuit boards, and magician chassis.
Okay, so well done. Hi, Rowan. Oh, hang on. Let me face. I'm down here, lovely. Okay, can you see me? Yeah, fabulous. Okay. So Rowan, that was absolutely phenomenal. Love it. Well done, you. Congratulations. Fantastic little robots. And thank you ever so much for doing those videos for us. Really, really appreciate it. So we've got questions which are starting to come through on the Q&A session on the YouTube channel. And we've had a lovely one from Helen. So what for you has been the most difficult part of building the scutters?
I think
the three, like sticking all the shell together and making it like sturdy enough to run. What else?
And so we can see that you've made the two robots which are just behind you, and they look really, really good. They are 3D printed. How did you find doing the CAD design to make those robots?
I really enjoyed it. It was quite difficult to get the shape of the head, especially. But I think it looks pretty good now.
It looks fabulous. And looking at the big blue scutter that you've got behind you there, we noticed that there's a lot of lights and bits and pieces which are twinkling away in the head. Can I ask, you haven't got any cables between the head and the main body, so how did you get the lights to light up?
Well, I've got a small Arduino in the back of the head in the secret, not so secret compartment that I programmed to light up, and then there's also a small speaker.
That's fabulous. So Rowan, is there any robot that you would like to make in the future now? What's your next big project?
I haven't really thought about it, but I think a Crichton head or something. I don't know.
Wow. Now that does sound fabulous. And can you imagine sort of 3D printing a Crichton head and doing all the engagement side of things with it as well? Yeah, that's great. Lovely to see you, and thank you ever so much. In fact, we're going to be coming back to you a little bit later on the day because Rowan has done some other talented little devices as well, and so we're going to be coming back to you live a little bit later on. So thank you ever so much for that. Really appreciate it. Have a good day on Beach Lab and enjoy yourself, and we'll see you a little bit later.
Thank you.
Thank you, lovely. Bye. Okay, so we're back. Hang on, let me move again. There we go. Titles coming up, folks, so you can see what's actually happening as far as the next schedule is concerned. We've got happening shortly, and I'm very pleased to announce this, is the fact that we've got Razor, we've got the double world champions coming to join us, which is brilliant. In fact, Razor was due to come to Beach Lab, and we would have had the Razor team with us on the promenade. Unfortunately, circumstances haven't allowed it, so instead we've just done slightly different. We interviewed them. It's great. We've done a creative competition. A lot of people have taken part and sent us in stories as well as other bits and pieces, pictures of what has been going on. And so we're going to be doing the creative competition results for that and the winners. And then we go from one big sort of fighting robots to smaller little fighting robots. Sumo bots. It's a new sort of little thing which is taking off, and we'll be going through to some of the bits and pieces. Things that are going on during Robotics Week. This week, it's not just Beach Lab today. There are other things that are going on. Monday evening, we have an evening with robotics, which will be live on this channel. We have 3D design with Tally on Wednesday. On Thursday, we have an electronics workshop with Thomas. And on Friday, we all get together and get incredibly drunk and have a robotics pubs quiz. And so, and all week, if you want to, if you are home ed, or if you're if you've got youngsters who want to actually make some of the robots, then there is Robot Crafts, which is available, and there's plans and bits and pieces which you can pick up and download and give you some ideas of what to do. And all that can be picked up at the URL, which is at the bottom here now. Also, you can find other information regarding the club at aberrobotics.club. But without further ado, it gives me great pleasure to introduce to you something that I was involved with, and something that really kicked the whole thing off 20 years ago. Robot Wars. And I got friends with a couple of guys, and it just took things to a different level. So we have Simon Scott and Ian Lewis, and they're from Bournemouth. let me give you a little bit of a CV as far as what these guys have actually won. It really is incredible. Robot was Best Design Robot Series 2. BattleBots Gigabot Robot Rumble in the USA. Winner. Robot was Pinball World Warrior Championship Series 3. Winner. International Championships. Winner. The Southern Annihilator Series 4. Winner. All-Stars Champion for Extreme 1 and Extreme 2. Double World Champions. That's good. Robot was UK Champion Series 5 and Robot was Best Design Award in Series 5 as well. So I hope you enjoy this. It's quite a long interview. We had loads of fun doing it. And just to give you an idea, well, who is Razor? What is Razor? What does it do? We've got a little bit of a clip for you to enjoy. See you in a bit.
Hi, I'm Ian Lewis.
I'm Vinnie Blood.
And I'm Simon Scott.
And this is
Razor.
I want revenge! You can't make me look like a daft old... what? I'm not too sure. One hates to think about descriptions for Matilda, really. Stuff of nightmares! Oh, look at that! They've driven straight onto the Razor beak! And Razor know! That's Vinnie Blood there with the thumbs up. They know now they've got Onslaught. They can do with Onslaught exactly what they want. And that is to let them go, because they know they can come in and crash. There was an attack of the beak weapon. They've got Onslaught by the tyre, by the wheel, a crash. And Onslaught, well, the tyre slightly, only slightly shredded, and it looks to me as if they've got full power and momentum. Or have they? Razor again worrying and nagging, and they pace themselves magnificently in this Southern Annihilator to come strong at the end. Onslaught, well, we better have a go. Charging headlong at Razor. Do you know, I'm not too sure whether they've got full crushing ability or whether they have done throughout. The tyre now fully shredded, so the damage was done. Look at that, the tyre, which had been shredded in the earlier attack, seemed to be okay, but no, it wasn't. And that will be a major problem now for Onslaught's traction on the arena floor. Razor bumps and bashes. Again, almost tentative, though, with the claw. Almost as if they don't want yet to pierce the steel chassis and the covering armour of Onslaught. Onslaught away, beyond Matilda, beyond the flame, spurting out from the arena floor. They're the remnants of its tyres. Oh, what are they doing? What are they doing? Straight back into the CPZ, in comes Razor Onslaught on its side. And I mentioned beforehand, if it was flipped over, it could stream itself right, but not on its side. I don't think so. Against the arena wall, and Matilda pressurised and punctured by Razor. Oh dear, look at that. Matilda taking one on the shell. The rear of Matilda has never been quite seen like this before, and I have to say, thank goodness Matilda is on fire. Razor is destroying Matilda. There's the flame from Matilda. The tusks were raised. I think it was just a last sort of nervous spasm of Matilda. They're in major... Tildy, what's happened to you? Call on all your friends, the house robots. Kill a lot, do the gallant thing, take on Razor. Onslaught's long been forgotten. Matilda, kill a lot. You're a knight of the realm, sir. Get in, sir, and protect your Tildy. No, sir, no such fear. We'll let Tildy bear the brunt of the attack of Razor. Is there anything left of Matilda, I wonder? Onslaught, there's Sergeant Bash to have a jet. There's nothing left of Onslaught, I'm sure. And just when Matilda thought she was away, back come Razor. Down goes the pit. Go on, chuck Tildy down there. Get Matilda in the pit. Oh, Matilda, what's happened to you, dear? I think it's time you took a long rest, Matilda. Go on. Take a long convalescence, Matilda. Killalot, was Killalot nudging Matilda towards the pit there, everyone? I'm not too sure. The house robots seem to be teaming up with Razor against poor old Matilda. What's going on? Vinnie Blood and the Razor team have won this Southern Annihilator. Poor old Matilda, ladies and gentlemen, boys and girls. What on earth has happened? to the darling of Robot Wars, Matilda. Yes, I know, it's sad, isn't it? But she is our darling. Oh, Matilda, we will not waltz with you for a while, it would seem. On the flame pit again. Well, Onslaught, eventually. Dead Metal doing the right thing by Matilda. Onslaught in the pit. Razor have won the Southern Annihilator. And now Sir Killalot can come in for revenge. You're a little bit too late, Knight of the Realm. But what's to happen to poor old Matilda from now on in the red pot? Taking one last lingering look. Will this be the last we ever see of Matilda, I wonder? Razor, strong enough to be our Southern survivors.
Right, so, well, a very, very warm welcome back, and it gives me great pleasure to be able to introduce two old friends of mine from many, many, many moons ago, and from the days of Robot Wars back to the, late 90s and early 2000s. So it gives me great pleasure to introduce you to Simon Scott and Ian Lewis. Welcome, gents.
How you doing? How you doing there, Steve? God, it has been a long time, isn't it? It's been
indeed, yes.
But some incredible experiences over the years, some amazing inventions, and Simon, we had a right blast doing all this stuff, haven't we?
We've had quite a journey, but it's at times.
Well, it's great. It's great to have you join us, guys. I'm really, really grateful. It's a fantastic experience for a lot of the kids who obviously grown up with the Robot Wars and obviously the iconic robot Razor. We've had which has been fantastic, a lot of questions from some of our club members who are quite keen about Robot Wars, and obviously Infinity from myself, and the iconic Robot Wars robot, which is Razor. So from Patricia and Tally, we've got Razor is a piece of art as well as an amazing killing robot. How did the design come around?
Quite a thing, wasn't it, really?
That was in the days of fax.
Yeah. Faxing little sketches backs and forwards. I think the original design was really like a bulldog. We thought of, British bulldog. How can we get on the BBC? How can we kind of, get selected and get on there? We were desperate for any sort of ideas, weren't we? I do remember the bulldog one. What was the other?
That was it, because we were watching the very early series of Robot Wars Series 1 that we weren't in. So we were basing our idea on what we were seeing each week on TV. And I think it must have been, a few weeks.
We saw Mortis, didn't we? We saw some
one time they turned up gradually as we were seeing machines on there that we ended up. We thought that the Axe robots were unreliable. They were getting a hit.
Pretty good though.
Unreliable. Spinning discs weren't allowed at that time.
Yeah.
So quite quickly, this grab hold of idea came about. I'm just laughing at the faxes because we were both supposed to be working at the time, but we were doodling ideas, and that germ of Razor was coming out. I used to look forward to receiving a fax on a piece of A4 that the latest doodle for me, and then I'd modify it and send it back.
Our recent generation may not know what faxes are.
Yeah.
It's sending pictures via a telephone line, isn't it? Yeah.
Yeah. So originally, that idea of a jaw machine just got bigger and bigger. So we figured that, if you had a bulldog, it was pretty handy at biting, but you weren't going to readily get hold of other machines. So you needed something pretty big. So this big kind of plier or a big jaw machine sort of started to appear. And we figured high centre of gravity, maybe we could make it look good. Slim it down a bit. I mean, do you remember in your house, we made a huge thing at first. It was enormous, wasn't it?
Off the faxes and the doodles, Ian made the first a cardboard shape, which actually was close to this, but it was twice the size. And he brought it round my house, and we looked at it, and I said, we'll never get it. It's 80 kilograms back in the day.
80 kilograms.
And I said, there's no way you're going to get that in the 80 kilos. But we had, I think by that time, we had a battery. We had a battery, we had
lead acid,
we had the drive motors, and I think we might have had the hydraulic pump by that point, by the time you had made the model. And literally, we cut the cardboard prototype down, we kept trimming cardboard off it until it was as small as we could get it and still fit the components in. That's why you see some bulges here under the armour, because it just ended up that compact. But that was the only way. I said Ian was hard to convince. I said, we've got to make it smaller. We have to. We'll never get it in because we were going to use 5mm steel plates. Is the main plate used throughout, because it does weigh. You know?
Brilliant, brilliant. So how would, second question, boys, how would the design of Razor evolve in future generations of the robot?
I think something that we were very tempted to do was, as more exotic materials came along, titanium.
Yeah.
And we were using quite a bit of titanium in the machine as we were developing it anyway. We developed it pretty much over 2 years, didn't we, of competition.
Yeah.
And we really favoured the arm, being made of tie. It would have been fantastic to have done that. Also, the drive motors, brushless, a lot of power, a lot of horsepower. Of course, lithium batteries. I mean, the artistry side of the machine. What any thoughts on that? How it might develop and become more crazy?
No, I think shape-wise, we nailed it. Unless you were going to make a completely new one and use lighter materials and then upscale it, there's a chance that we could have actually made one, 30% bigger using more modern materials. But then it wouldn't be Razor. It'd be Razor 2 or Razor Squared or what. This was toyed with when the weight limit did go up in the early days. We did and ah of just building the same thing again, slightly larger. But we kept with the original.
Brilliant.
There was one crazy idea, which might be quite an interesting one. There was a certain sponsor we were looking at, trying to sort of placate an interest, and spray Razor bright orange. The whole thing bright orange, gloss orange.
No, I don't think it would work, could it? Apart from showing all the scratches and other bits and pieces.
Yeah.
That's the reason it wasn't painted.
Yeah.
Because we were watching how the judges were marking the early competitions, and scratched paint was classed as battle damage.
Exactly.
So that's hence the whole thing was kept raw.
Yeah, and obviously an absolutely iconic, robot. Okay. So next question from one of our club members: what is actually inside Razor? What's inside Razor?
Nothing.
Well, I remember the old motor controllers very well.
Very secret things.
So what drives the beak?
Yeah, hydraulics.
So we've got a 3-inch bore hydraulic ram in the very base of the machine, right at the very bottom, literally just above us, a few millimetres above ground level, which is there, runs the full length. Just a very straightforward principle. Then a 3-way exchanger valve system up in here, a hydraulic pump here, a small motorcycle starter motor there, because this is, we didn't have brushless technology in those days, so we used what we thought would work, and actually those starter motors work really well. Even if the motor turns to charcoal, it will still run. So it's a really basic 2-way hydraulic system, but it was made out of scrap. These were all scrap parts that we found, because people who build robots today, they tend to source new componentry. But when we saw the ethos seemed to be make a robot out of odds and ends and what you can find lying about. So pretty much most of the materials in the original Razor, it was from the scrapyard. It was just scrap parts.
And really, we found with the design, it was quite useful because Simon really came from a hydraulics background. I came from pretty much an electronics background as well as mechanical. Of course, Simon mechanical as well. So we both had the mechanical design capability, but we both had our little sort of speciality, mine being electronics as well, Simon being a hydraulics sort of background. And the machine, if you look at it on the left-hand side, it's got the hydraulics all down that side. and then on the right-hand side, you've got all the electronic drive on that side. So we can actually place the machine on a table and work on it between battles. You know, we've got one side each. It's all worked out quite well, really.
It's really lucky, really. I think actually the reason it ended up like that is that we had to keep the pipe runs from the hydraulic as short as possible. It's all to do with weight limit again. So hence why all the parts are as close together as they could be. So that's why you don't have hydraulics going from one side of the machine to the other. It's literally as compact as you can make it, and that's all. It's constantly weight. Weight was the big thing. How can we make this thing? But it's got to be in the weight limit because it's too heavy. They're not going to let us fight with it.
Quite. Question from me, boys. Question from me. Are you still using the 3QD motor controllers, or have you changed?
They did change. Yeah, the 3.
Because they were quite large, weren't they?
Yeah, they were pretty good for a while. But what they had, and you might have seen Razor do this as it went on, they had a kind of thermal shutdown, level shutdown. So what would happen, they'd heat up as the battle went on, and then you'd see Razor almost looking like it was running out of power. But what that was really was the 4QD was limiting itself gradually down to stop itself from burning out. And actually one day, I rebuilt a Razor in the garage. Do you remember when I plugged it in? And I jostled the plug in to test it, and this was Sunday evening, and we had to be there Tuesday, I think.
All right.
And it went bang, and the whole 4QD just blew up. So it just burnt it out, and we were in a bit of a fix, really, to be honest. I think 4QD did help us out, which was really good, but we ended up in the end changing to H-bridge MOSFET, which was part of the sort of other robot stuff that we did with Ming.
Yes.
When we worked with Ming, yeah, we had those speed controllers, and they're still in today. Actually, they work sort of pretty well. Really, speedy, aren't they?
Yeah, because the way that the motor controller side of things has moved on technology-wise now, a lot of my heavy robots, my entertainment robots, are all working off saber tooths, and the nice thing about it is that we can include Arduino control into them. So it makes them now semi-autonomous, which is great.
Wow.
Anyway, enough of me. Back to the questions from the kids. Okay. What's it like to control the robot and drive it around?
Right. Well,
so we had two guys here. Both of you are controllers, aren't you?
Yeah, both of us controlling it. So you go first. What was your experience like controlling it?
You've got a control on it at home and experimenting and testing it. That's easy. But when you're in battle, or actually not when you're in battle, before the battle, that was the worst time for me. When we turned the machine on and it's left in the pod of Robot Wars behind those shutters, and you've got to walk upstairs up the galleries where we're gonna fight, and you're waiting. It's that anticipation is when you think, well, you don't know whether you've got what it takes to deliver. But as soon as they say 3, 2, 1, activate, then bang, you're in, and we're both just totally fluent. You become the two of us just become one with the machine, and you don't even have to think about it.
It was a lovely thing. We did a lot of external shows with Razor, and I sort of came from a background of radio control car racing, so like chassis design and custom build stuff. So to make something that handled was quite important, something that was so fluid, like a dancer. If you watch Razor's movements, it's very fluid. It spins, it goes round. And in a way, that's quite you can see some of the MMA fighters these days, they will spin, they will give like false moves and things like that and confuse the shape. And I think we actually, got the better of some of our opponents because they were just like, oh my God, what's this thing doing? It's spinning around, and suddenly it's on the bike. And what it was, we can almost control Razor with our eyes closed, couldn't we, in the end? It was so reliable and so beautifully fluid, very, very fluid movement.
So you were both controllers in that respect, weren't you? Because I think, Ian, you were the actual driver, and Si, you were on the beak, on the weapons?
Yeah, the arm. It's funny,
the arm, I'm sorry.
Call it beak, the head. whatever. But it was always the arm, which is strange, really, because there's kind of a face at the end. So why is it an arm? But arm comes from the early days of when we were constructing it mechanically. It just was the arm as it was being built. So
it became the self-writers as well, didn't it?
So the crushing arm also operates through a lost motion system. Operates the self-writers. And that was a nightmare to build that, but we realised after series 2 that we were going to go out. We were going to get tipped over. So we had to make the thing flip back on the wheels. But that was the hard way of doing it. There was a more easy way, but it wouldn't have looked as good. So it had to look good as well. So we did it the hardest way possible, but it looks the best, but mechanically it's just very, very difficult.
What about the story when we tested the self-writer and it went off bang?
It did go bang, didn't it? Far apart through the fence.
Yeah, we had a little old video camera, VHS recorder, and the machine was on its side, and it tried to come over and went bang, and there was this terrific bang, and Simon sort of went, oh, all bits have gone missing. We could hear stuff scattering around over the gardens, over the fence. And in 2 frames, you could see the spring washers come off the back mount and just explode past Simon's head. It sort of came just past here.
Oh, the joys of testing.
We tested the cable on a 1.5 ton trolley jack, and it couldn't snap the cable absolutely leaning on it. So that was getting at least 2 ton on the cable. But then Razor in the tests, Razor easily can exert more than that, and it just burst it.
Off it went. Oh, fabulous. So, okay, next question, boys. What is the best and worst battle moments?
Oh, I suppose.
So, no, this is just Razor now, not Warhead, just Razor.
Just Razor. I suppose for me, my best moment was the Second World Championships when I realised we were getting the better of Drillzilla. Drillzilla was this really hard, tough, powerful, kind of processive walking machine. And it was very quick, and it had pushed everything out of the way, hadn't it? All day you'd hear this V8 thing like going around the arena. And then I thought, how are we going to take this thing on? This is
absolutely funny thing, Drillzilla. I drilled it into you pre-fight. Do not let that thing get on Razor's side. If it gets on the side, because it had two large steel sort of rigid appendages come out to corral you. And I said to him, I said, if that thing gets on the side, I said, we're done. You just whiz us straight in the pit, and that's it. I said, you've got to either manoeuvre out of the way or keep the mouth end of Razor facing Drillzilla, so as if he comes towards us, he's going to ride up in there. And that's what we did. But it wasn't a give me at all. That was heavy, and that was 3 times the weight of us.
Yeah, it was 160. It was allowed to be, I think. Wow. But the worst. Sorry.
So that was this. So was that the best or the worst of your battle?
That was personally my favourite moment when I realised we were getting the better of him. I thought, wow, we can actually
win the World Championships.
We started to get hold of his feet and started to jam him, and I could see smoke starting to come out. And I got Simon into a really good spot, and he brought the old beat down, got a good bite on. Simon's got to be really ready, with the beat just perfect to get hold and get in there, because hydraulics are quite slow. So
that was on his processive legs.
That's it, and he jammed it, didn't you?
Yeah, when we clamped them, he will burn a motor out. He just will.
20 horsepower. I think he was about 20 horsepower.
Yeah, and we managed to stop his processive legs moving. He kept flooring the throttle and eventually burnt out a drive motor.
The smoke coming out.
And it's that touch of smoke that comes out.
Yes, come on!
That gives us a win, because that's damage.
Yeah.
But otherwise, there was limited to what we could do, because it was so thick, it was about that thick in plate. We weren't going to pierce it at all. We could only clamp him, so we had to do damage, and that was the only way to damage it, was to damage the internals through grabbing the moving component.
Wow. And so, guys, what unfortunately is the worst part or the worst moment within Robot Wars?
Well, yours is going to be. I'm going to add my best one, Steve.
Okay.
We know what the worst one's going to be. But my best one was the series of fights that was the Southern Annihilator.
Yeah.
And I believe it was only showed on TV once. And a lot of people missed it. And it was such a good series of battles. There was so much rough and tumble. We were lifted and flipped and rolled around the arena.
Gemini, wasn't it? And
I'm not sure. Honor Behemoth was in it, and over Onslaught, over whatever.
Carousel.
Yeah. Attila the Drum. Right. Also, you'd have to find it, but that series of maybe 5 fights to the trophy for me was the best, because it was just so action packed. We'd come out from one fight, we'd have fans under Razor trying to cool it down, trying to recharge the batteries, cool the motors. Literally, the crew were radioing us to go back in for the next fight. It was so intense, and all the battles were just really thrilling. It was excellent TV.
It was good, actually.
Ah, fantastic. Special times, boys. Special times. So, okay then, Ian, what is the worst part? What's the worst part?
The worst moment was when Philippa Forrester didn't say hello to me when we were going down the corridor. It was so sad.
Yeah, what's the real
sulking for a week?
Well, everybody knows it. It's a pussycat fight. Oh dear. It just got to me. I don't know what it was. I think it's kind of, Razor, I think by that point we've built up quite an attachment, or I certainly had, to the machine. I think Simon had as well. It was kind of like your best pet, your pet dog, And to see it in there just getting beaten and beaten and beaten. And I put the radio actually down in the end, because you used to be able to sort of steer across. And I figured maybe they sort of see that, and now they just kept beating and beating and beating and beating the machine. And I just couldn't watch. So I walked off. And I just couldn't face it. It got to my kind of soul, really, didn't it? Oh, I think it's outside for an hour.
I think it was we weren't able to fight back through some tiny little electrical fault, which we found out after. It's just a tiny little switch. Just meant that we couldn't deliver, the fight that it would have been. So, but you have to take it on the chin. It's part of the rough and tumble of it. It was bad, but in actual fact, the damage was superficial. Really, we were quite lucky that the armour did it. I mean, the armour got ripped to pieces, but internally, it was really quite surprising to see how intact everything was.
And amazingly, actually, we had a rematch, and he beat us again. And it sort of turned a funny thing, because we became very, very good friends with the family, with what was the lad's name? And the lad's name? I can't quite remember, but the lad was really amazing at
driver.
Gribble. Really incredible at model car racing. So he was really brilliant at controlling Pussycat. Really something. Yeah, very good.
So, Si, what is the worst one for you?
The worst one? Well, it's a kind of, I say disappointment. My disappointment was the Series 5 final. Now, it's a final that we won, but for me, I wanted a showier final. We were actually geared up to fight Hypnodisc. We were so close to having the Hypnodisc and Razor final that everyone wanted.
Yeah.
Hypnodisc made a silly mistake. I think got pushed down the pit.
Yeah.
And then Bigger Brother came through. But for me, it was an anti-climax fight. So the fight could have been better in the end. He was goading us. He had some sort of drive issues. I think we'd clamped down on his armour. His drive chain had gone tight. He couldn't quite manoeuvre, so he just went over by the pit and was goading us to go over near the pit. You wouldn't go over near the pit, and it just ended up a stalemate sort of thing in the end.
I know what that was. I think we wanted to win the big trophy, the grand trophy, at some point. And I think we fell out of sync with that, Simon and I, a little bit, because the bravado of Razor's performances, I knew, was causing the machine to age very quickly through its rounds. in previous times, and the machine would some point would fail. There'd be some sort of unreliability. So I said to Simon, no, the machine's got to cruise through all 8 rounds to make it. And even the final, the bravado has got to be just pulled back a bit. And it was a difficult thing to do because Razor is all about the performance and all that. But Simon, I think, you know, although he didn't like it, he was good enough that he kind of was like, well, yeah, I can see where this is going. It's fair enough. The machine's going to make that longevity, you know.
Because I was yelling at you, because you wouldn't go after bigger brother. I was yelling at him.
Yeah.
Go and buy a Killalot. Because he's driving. I can do this on the arm. Right, I've got to be near something to buy. I was yelling, go and get a Killalot. And he was like, no, it's too risky. Too risky. We could lose. Something could kill a lot of pushes in the head. So it was that for Ian, it was the fear of losing through something simple, which I understand and respect. But it does happen in competition. Often competitions are extremely exciting right up to the final moment. But as I say, there was a degree of preservation there in order to get the trophy. But it would have been nice if it was more touch and go from a televisual perspective.
Feast.
Yes.
I think one of the most memorable ones, I think you guys seem to have a bit of a ding-dong between yourselves and the house robots. And there was quite an iconic one where you managed to sort of have a bit of a bite to the back end of Matilda. And that was well done in history, boys. That was a good one.
Okay, that's a good laugh, wasn't
it? Yeah, actually, that was that not in the end? Annihilator. That was in the end of the Southern Annihilator.
All right.
Yeah, classic. That well worth a watch.
And the guys, the guys who were behind the scenes on the house robots as well, they were really great guys. We used to sort of go and chat to them and look at, pay some interest with the house robots were quite rough kind of things, actually. When you looked inside them, sometimes it was a bit surprising that they worked, because they were sort of cobbled together. But they were pretty effective, weren't they? And the guys were well up for it. So we knew that it would all be taken in the best possible taste, and we just went for it.
Wasn't it great? Fabulous times, boys. Fabulous times. Okay, so we got a question from Rowan to each of you. What was the first robot you ever built? What was the first robot you ever built?
Do you know, I thought about this, actually. Yeah. Now, something occurred to me that happened quite some years ago. And I would say the closest thing was when I was 5 years old, I built a time machine in my front room. And this consisted of a couple of Tesco's boxes and a Co-op box and some crayons. And my granddad, being a clockmaker, had lots of clocks, old clocks that he'd given me. So I'd watched the film, the famous film H.G. Wells, the Amazing Time Machine, which is a very ornate looking thing. And I thought, I'm going to make one of these. So I had this clock apart, and Mum said, blimey, you had that clock apart. And put it all back together and sort of seemed to know what you were doing. All the cogs were everywhere and springs and everything. And then you attached it to your time machine, wound it up. And of course, what I'd done is I'd made the mechanism so the arms whoosh round like on the film. And I was sat there like, on the controls. Yeah. So I think that's probably the closest thing I can remember right back to.
That's brilliant.
I can remember in middle school drawing a dinosaur, like a Tyrannosaurus Rex. I drew one made of metal, so it was all made out of plate, all riveted together. And for me, it was a good drawing. It was about so sized, and it got pasted onto a big panel with all the other children's drawing. Anyway, there was a raffle or whatever, and someone else won it, and I got to take my drawing. So that was the end of my first robot drawing. I was definitely about that.
Yeah.
And then I think out. I used to make things. I wasn't a fan of Meccano, bizarrely, but I would find other pieces of metal lying around and bolt things together. Look, I remember making a little stand-up robot out of metal shapes that looked quite good. It just had two curved arms. It didn't do anything. It just stood. It was just out of metal. So they were, practical experiences. No, nothing to do with it. So I mean, the first real robot we made, obviously, was Razor. Yeah, that was like, this is our first attempt.
That's it. But that was your sort of, there was something there in the background that inspired you. It's the same with the kids, that inspires them to get them engaged and involved and to make their own robots. And obviously that worked for you. A good question from Andrew. Did you digitally model Razor before making it? And if so, how? Well, we're talking back to the 90s now, so it was CAD. So if you didn't have the CAD then, boys, how did you do it?
So really, I mean, we completely did Razor old school. Way back then, I can remember Arthur Chilcott from Mortis, and the guys there, they were from the sort of university side, and I can remember SolidWorks being kind of handed out to the Robot Wars guys for free, which seemed amazing, really, from SolidWorks. They were obviously seeding the market a bit, and I think that was late 90s. And I sort of took a bit of a passing interest in it, but it was kind of like, you know what? We've always done it with cardboard. So cardboard was the big thing, wasn't it?
It was. Well, the things you have to have the imagination and the design of your potential robot in your head anyway. And then and for us, it was just easy to get it out on bits of paper on cardboard. Is just a great thing because you can sketch, you can make something full size. Particularly a shape like this. I mean, the Razor shape lends itself easily to be made out of cardboard construction, just as the chassis anyway, just to get a scale. But there's nothing like when you make a simple model like that, it gives you a sense of perspective. Well, we realised that the original cardboard model would have been too big, to actually make the real thing, but you wouldn't have got that perspective if you brought a drawing round or a digital rendition of Razor in those days. We wouldn't have known what scale that would have to have been, and then we could have started making the machine actually too big, and we would have been in a whole pickle. And actually, we wouldn't have made Series 2.
It's kind of like, now I work as a CAD designer, so I'm designing machines and all this kind of thing. Let's go back into
that. As the phone goes off.
The miracle of technology.
Yeah, technology, where would we be without it? Really is quite incredible how the way the different things have developed. In computing, in motor controlling, in so many different bits and pieces over the past 10, 20 years, boys. It's totally different, So we've got one question. Myra Wilson, who I'm not sure if you remember her. She was actually one of the judges on Robot Wars. In fact, she's one of my colleagues at the university, and she's obviously involved in intelligent robotics and artificial intelligence, etc., etc. And Myra has actually not only sent her regards, but she also comes back with a question for you boys. And she's come back and says, "So, what did you think of the judges' decisions?"
They were pretty good. I always said that whatever the judges decided, I'd pretty much go for. So I'd go in there, give it 110% if you can. I know it seems impossible, but you can go in there, you give it absolutely everything, and then go with what the judges say. We did run into a bit of trouble with that later on, actually, within the team, quite famously. And I think it's one of those things you just got to rely on. You've got to say to yourself, I'm going to put that stake in the ground and then go from that point there, so that I've got no regrets either way. And the only one decision that sort of sticks out for me is when we were for NATO, they had a big rotor on the front, and they had a little motor that was driving it, and we sort of destroyed the rotor and pulled that motor out And the judges, it was a real 50-50 sort of split. They came into the arena and they looked at the damage of the two machines, and they thought the motor was the same size as one of our back wheels. They thought one of our back wheels had come off. So that was the only time that I thought they really kind of got it wrong.
They did. I think they did admit that was the pivotal thing.
Yeah.
But you were marked down because you lost a wheel, or we didn't lose a wheel. But it's just one of those. But luckily, that particular fight wasn't in, shall we say, one of the more serious competitions. It wasn't anything to do with a major trophy as such, was it? So our progression, we didn't lose out on any progression towards a world championship or a series finale.
I think it was just that we were so competitive with Tornado then, and thankfully so, it was a fantastic time. I actually met Andrew, not so long ago, actually, and had a really good chat with him. We became good friends. It's always the same, isn't it? Great rivals become great friends. Because the thing is, if you're going to step up to that mark, you need somebody who's willing to step up there as well and challenge you as well, so that you can drive on and drive on and drive on to greater heights. Otherwise, you're just going to kind of become a bit stale, I think.
Well, talking of that sort of development and side of things, obviously you guys are incredibly talented. The iconic robot that is Razor. You then moved on to the BattleBot side of things with Warhead. But I think that's enough information for another sort of chat at some later stage, because that is a whole chapter in itself, and quite an exciting one. So really, guys, I just want to say thank you for answering all these wonderful questions. I really, really appreciate it. And for us, myself personally, the experience that we all had together, taking the robots out, and for me, one of the exciting ones was when we used to put all the robots into the arena at the end of the day, and you just used to have a melee and see which one was standing at the end of the day, which was just great fun. So I just personally want to thank you ever so much for involving me, my son, and a whole load of other people. And we'll look forward to having a possible interview about Warhead at a future stage.
Yeah, brilliant. Thanks so much.
Thank you, guys. Big round of applause. Razor! Good, there we go. There's a good couple of memories from quite a few years ago, and that was done last week, which is the Razor team. Unfortunately, they were supposed to come down to Aberystwyth to be with us here at Beach Lab this year, but unfortunately, due to circumstances, we've had to do it all online. So a very warm welcome back. Lots of things happening today at Beach Lab online, rather than at our bandstand at our usual location. So we are now, during the week, we have up until Robotics Week, we've been organising competitions, and through the website, the competitions have gone out to quite a few people, and bless them, they've written stories or they've drawn pictures, and we've had a set of judges who have all come together and gone through the particular entrance. And so we're going to move on now to Patricia and Tally, who are the sort of instigators and judges behind it. So I want you to just introduce you to Patricia first. Patricia is a lecturer in computer science for Aberystwyth University. Extensive knowledge in robotics, and does research on how robots learn about objects and the physics of the world through childlike play behavior. And Patricia is the leader of our beginners section within the Aberystwyth Robotics Club. And Tally is our outreach officer for the faculty, an incredibly talented lady, qualified secondary school teacher, science teacher, and is the latest member to join the Aberystwyth
Robotics Club in organising Robotics Week. So a huge thank you to the ladies for organising the bits and pieces on that. We're going to go across to them, and then we're going to have the results of the competitions.
Hello again. I'm very pleased to have the opportunity today to announce the winners of the robotics competition this year. So the robotics competition was split into two sections. There was a design the robot competition, producing a poster describing a robot and what it's able to do. And then there was a story competition, and we broke these down into various age categories. And what I'd like to do without any further ado is introduce the various poster competitions. What I will say is we didn't have as many entries this year as we would hope, but so I'm going to show you all of the entries that we did receive, and I'll show the submissions that we got there and the winners in each of the age categories. So without any further ado, I'm going to share those with you, hopefully. So in the first age category, this is the 8 to 10 age category, we have a robot design from Oliver Lerigo of Ocean Bot XL. It's a lovely robot design of an underwater robot that's able to actually drive around using remote control. It's got a searchlight so you can actually see where it's going, and the camera so the searchlights will light up where it's going and the camera can then see, and it's got a retractable claw on there. And I really love the attention to detail here, giving the dimensions for the robot, considering the propulsion as well, so having a nice propeller at the back there, but also thinking about the distance requirements for the remote control. So a very nice description here, saying that the controller can never actually be more than 2 kilometers away. So I think that's really nice attention to detail, and that is our winning entry for the 8 to 10 category. Moving on to the 11 to 13, we have an entry from, and I apologise for the name pronunciation here, I'm almost certainly going to get this wrong, Yaye Aidan, a futuristic robot. We can see a very nicely drawn robot there. As you say, this is the 11 to 13 age category. And we've got a few entries in this category, so she'll build up to our winner in this category. Here we have, so this is Mech X1, and a robot designed by the greatest minds in the galaxy. There's not much to say what the robot can actually do, but I'm sure if it's designed by the greatest minds in the galaxy, then it will be a very useful robot in the future. Be nice to see a bit more detail there, though. Carrying on through in the 11 to 13 category, here we have eco-friendly owl, and I love the detail here. A very nice drawing of an owl, enhanced with additional skills and technology. So it's got those super sensitive ears for being able to hear lost and stray animals, really important. It's got a very sharp beak. I'll definitely be watching out for that beak. And eyes that can hypnotize people. I'm glad that it's only going to use those when absolutely necessary, and hope that isn't necessary too often. But the other functionality that it's got, a post box for storing letters to post to people. I wonder where that idea came from. Very nice. Solar panels for charging whilst flying. Very useful. And then the particularly useful features, it's making it an eco-friendly owl. Its feet can actually burn things up, such as plastic waste, or if it's not able to destroy it straight away with its claws, then it's got storage space under its wings for keeping hold of it until it's able to dispose of it. So very nice design there. But on to our winner for this category. We have from Chloe Rowe, Firebot. And it's a lovely, very detailed, very lovely drawing there of a robot. I like the fact that this one isn't actually, it's not a humanoid robot. We just had the eco-friendly owl from Rebecca Clark, which is also not a humanoid robot. But I think this one, with the extra detail that it gives there, is quite an extended description about the robot. And a very technical description as well. looking at the different types of fire extinguisher that it's got in order to be able to break the fire triangle to put out both electrical and non-electrical fires. It's also got very useful functionality for helping people rescue anybody trapped in burning buildings, so such as using its infrared cameras. It's also to be able to detect the heat signatures of people. It's got a torch in there for lighting up dark areas. And it's got fire suppressing ball in the middle of its head, and various other functionality that will enable it to be remote controlled as well. So I think that's a really detailed, very useful, very practical, well thought out robot to be able to provide a good service there. So that is our winner for the 11 to 13 age category. And the other age category where we had an entry was 14 to 16. And this is an entry from Zachariah Aiden. And here we have Omni, not quite so clear on the details, but it's apparently a robot that does everything. Quite what that is and how it does it is not very clear from this particular design. But it's a nice drawing of a robot, and it's the only entry in that category. And that is our poster entries. So congratulations to each of you. We will be in touch with the winners there to send out the prizes to you. On the story side of the competition, we actually had a lot more entries than from the poster side. So we're just going to read out the stories from the winning entries. We have entries in the 5 to 7 age category, 8 to 10 age category, 11 to 13 and 7 plus. So a nice spread of entries there as well. Now I've asked my esteemed colleague Natalie Roberts, our outreach officer, to read the stories for you. So I shall pass over to her for each of the winners in the category. So first of all, in the 5 to 7 age category, we have the story by Isa Bosch, My Robot Friend. Over to you, Natalie.
My Robot Friend by Isa Bosch. Once upon a time, there was a boy called Bob. One day, he made a robot out of cardboard boxes, wrapping paper and foil. Over his head, Bob put a bowl that looked like the robot's head was inside a bubble. Bob called the robot Bubble. And can you believe the robot could speak? Bob and Bubble became best friends. One day, Bubble said to Bob, "You'd come with me to the land of robots." "I would love to," said Bob. "Well, should we start to go?" said Bubble. "But how can we walk there if it is so far away?" said Bob. "You will see," said Bubble, climbing down the window. "I will probably need help to get up," said Bob. "Okay," said Bubble, stretching out his hand for Bob and lifting him down. "Watch now," said Bubble, lifting up his claw arm. Then a zap of blue light shot out of his forehead and a door appeared in front of them. "Let's go into it," said Bubble. "Okay," replied Bob. They both went into the land of robots. "It's amazing," said Bob. "Yes, I know," said Bubble. "Let's have a look around." "Okay," replied Bob. Then they saw a candy floss maker. But everything was going wrong. There was candy floss everywhere. "Oh no," said Bob. "What is going on?" Bubble said that someone was ruining all of the machines and they have to find out who. "Okay," said Bob. So they went to look around and see if there was anyone sneaky. Then Bob saw someone running from the candy floss maker. It was Robbie, the rude robot. He was making trouble again. "Bubble," said Bob. "Look." Bubble looked. "Oh no," he cried. "Let's go after him." "Let's go," said Bob as they ran faster and faster till they got him. And Bob said, "Do you have any handcuffs, Bubble?" "Yes," said Bubble, giving them to him. "You put them on him for me and I will call the police. I'm the fixer for the candy floss machine." "Okay," said Bubble, putting on the handcuffs. Bob and Bubble saved the land of the robots.
Thank you very much. A lovely story and very well written for the age category. Moving on up to the 8 to 10, I'm sure you'll agree this is another very good story. This time by Thomas Bosch. I guess that might be an older sibling. And the title of the story is Robot Trouble. Over to you, Natalie.
Robot Trouble by Thomas Bosch. Max lived in a small house with his dad. His dad was tall and skinny with short frizzy red hair that stuck up, making him look like a crazy scientist, which was exactly what he was. In fact, Max's dad was always coming up with all sorts of crazy inventions. Max was very lonely. His dad never had time to play with him. It was the first day back to school after the summer holidays, and Max was already running late and really didn't want to be late on the first day. Max sprinted to school and snuck through the big iron gates. "Hey, Mad Max, late for school." Max saw Johnny and his gang of bullies walking towards him. Uh-oh, the clones, thought Max. The clones were a gang of teenagers who liked to pick on Max and make fun of his dad. "What's your dad doing today?" asked Johnny. "Probably trying to add chicken legs to your house." The clones laughed. "Loser." When Max got home that evening, his dad was very excited. "Max, guess what?" "What?" "Come to the back garden." In the garden, Max saw two huge metallic robots looming above him. "What on earth are they?" he asked. One of them seemed to be a cross between a jet, a car, and a drilling machine. It had wheels like a car, but its body was shaped like a pencil, and it had two wings coming out of its sides. At the front, it had a huge drill. "This is the Drillotron 2000. "Wow," said Max, "that is cool." "And this," he said, pointing at the other robot, "is the Thermo-Powered Magnetization Giant, TMG for short." It looked like a human, but much bigger, and instead of hands, it had two huge magnets. Max's dad climbed into the TMG. Suddenly, the giant moved and turned to Max. He could see the crackling electricity on the end of the magnet. Then a burst of electricity shot from the magnet, and Max felt himself being lifted up. He was hanging in midair. The robot moved its hand down, and Max landed gently on the floor. "Very cool," he breathed. The next morning, Max went straight to the back garden to see the robots, but one of them was gone. "Dad, the Drillotron 2000 is gone," Max cried. Suddenly, an announcement came over the radio. "Two thieves seen breaking into Bank of England in huge robot drill." Max and his dad looked at each other. "Uh-oh," they said together. Later that day, when his dad was not looking, which was quite often, Max snuck into the TMG. He pressed some buttons, grabbed a joystick, and began to move the robot towards the Bank of England. When he arrived, he saw the window was smashed, and there was a trail of money leading away from the bank. Max followed the trail until he found the Drillotron 2000. There were two people inside it who were counting money. When they saw the TMG, they tried to escape, but Max was too quick for them. He pulled down a lever, and the Drillotron 2000 rose into the air. He had caught them. "You were amazing, Max," said his dad. "What would you like? I can make you anything." "A Clones Buster 2000, please."
A very successful adventure. On to the next category, we have the 11 to 13. And here our winner is Isaac Sutton with the title of An Adventure with a Robot. Over to you, Natalie.
An Adventure with a Robot by Isaac Sutton. Today was a big day for Tom. It was his 13th birthday. His parents had promised him he could go to the new robotics factory in the city. Now Tom had always loved robots. He still remembers when he was 9, trying to build his own robot. Instead, he ended up paying for the repairs on Mrs. Crumble's bathroom window after the head of his robot came flying off and landed sparking on her bathroom floor. When Tom got to the factory, he was amazed with how big it was. There were hundreds of robots being carried through the air by a track of magnetic conveyor belts. As he was walking through the factory, he noticed a bin behind one of the exhibits. A glowing light caught Tom's eye. He walked over to it. The light started to flicker. As he got closer, he looked over and saw that there was a robot in it. It didn't look like one of the robots that were on the conveyor belt. It looked more modern and more updated. But before Tom could tell his mum and dad, a bright white light flashed in front of his eyes, and everything went black. Tom woke up in a small black room. He tried to get up, but he couldn't, because a rough rope was tied around him. Suddenly, the light turned on, and as Tom squinted, he saw a tall figure wearing a dark suit in front of him. In a small cage, Tom saw the robot from earlier. The robot's screen was a face that looked incredibly scared. "Now, you might be wondering why you're here. Well, you have ruined my plan to destroy every robot that ever exists." Tom's face looked horrified. These robots are taking over from humans. You had to mess up my plan. The robot recognized you as a human. It deactivated my explosive. As the figure was talking, Tom saw that the robot had used his laser cutting to open metal bars and was charging straight towards the figure. He sent him flying into the wall, leaving him unconscious. The robot cut the rope around Tom and let him free. "Where have you been?" shouted Tom's parents. "I'll tell you on the car ride home," replied Tom with a wry smile. That was the start of many adventures to come.
Thank you very much. And for our final winner of the competition, we have the 17 plus age category. And this is a story that really touched our hearts and really put a different spin on robots rather than all destruction and evil robots. So it's a story by Fiona Maha called Not Cinderella. And I hope you enjoyed as much as we did.
Not Cinderella by F.R. Mayer. Brushing my lips against her curls, I cradle baby Chloe to sleep. I will hold her all night, my perfectly regulated heartbeat soothing her. I never sleep. My ancestor was the earliest Bakelite clock radio. By a divulged unimate to my genus Machina hominis, the evolution that took you millions of years has taken us less than 2 centuries. But our history has not been straightforward. Just as superstition suppressed Renaissance scientific study, Asimov's 3 laws of robotics, suggesting the harm we might do if we went rogue, bred fear and strangled progress. Even the historical figure Stephen Hawking warned about the dangers of artificial intelligence, and for a century all development was limited. Chloe whimpers, and I rock her, each gentle swing simulating a human's gait. Half asleep, she sucks my finger, which monitors her temperature and checks her health through saliva analysis. My exquisite hand has developed from primitive mechanisms that could pick up eggs without crushing them, but do little else. Another lineage, cybernetics, began when the first proto-human used a stone to crush his enemy's skull. The rock was the extension of his fist, a flint the extension of his teeth, a digging stick the extension of his fingers. When humans melded their physical bodies to machines, this strength, driven by a Neanderthal brain, led to greater violence. The primitive urges of pleasure and pain are not reliable navigators. After the cyber wars, you turned again to AI. Now we pathfind across galaxies, mine minerals, and care for your children. Depending upon which dictionary you consult, the word robot means either labour, drudgery, or work. Such a human view. Raising your child and teaching her to be a good human is my privilege. Chloe turns in her sleep. I adjust to her new position and ask the house to open a window. A cool breeze fans her blonde baby hair. A hawk moth flutters in and settles on my shoulder. All life is precious, and glimpsing it from my viewpoint makes it even more so. I dim the lights, and without disturbing the baby, I glide to the window, where I tilt my body into the cool breeze. The moth hesitates, then lifts its soft wings and flies away. I watch it flutter down to the fragrant garden. You were so busy fearing us, you never considered we might show more compassion than you do.
Thank you very much. Another lovely story. I'd like to finish off with thanks to the panel of judges for the competitions that consisted of Sarah Taylor, an author of various children's novels. Steve Fern, who runs the Robotics Club, is also the creator and builder of the entertainment robots that we saw earlier, as well as being a previous Robot Wars competitor. Natalie Roberts, who was reading the stories there and who is outreach for the faculty, going out and engaging children in science outreach, and also myself from robotics and computer science. So thanks again for all the entries that we've had, and we'll be in touch with the winners to send you your prizes very soon. And hope you enjoy the rest of the day.
Okay, thanks Patricia, and thank you Tally. It's absolutely wonderful to see so many entrants that had come in from different people, and the imaginations out there for drawing through to story taking, absolutely fabulous. And welcome back to the wonderful world of robotics here at Beach Lab. We've done the competition side of things, and you saw a little earlier, we saw Razor with the big fighting robots. we're going to do a little bit of a twist now, and we're going to go to a thing called sumo robots. Now, this is something which is very, very popular in Japan at the moment, and it's starting to get bigger. We've started to do something very similar in the sort of Mid Wales area with the robots that we've got, and they're small, 2 kilogram robots. Yeah, I'm not going to say any more. Let's go and have a look and see what they're like. Hello, and welcome back. We're now going to talk about sumo robots. You've all seen the fighting robots that we had earlier on in today's session with Razor. The robots in Robot Wars are 100 kilograms. They are virtually the size of this days. They are incredibly heavy, and it takes 2 guys to lift a fighting robot. Robot Wars is not as popular as it was, obviously, because it's gone off screen. And so what we've done is we've created a smaller version. With Robot Wars, they have to use the radio control systems. But that was the technology that was available 10, 15 years ago. With the use of Arduinos and very, very small computing, you can actually have semi-autonomous robots. Here's a range of robots here which have been made and designed, and we run local competitions. So to give you an idea of the types of robots that are available, here is a commercial one. This is what's known as a Zumobot. It's a commercially made robot. They're available for just over £100. But it's not just simply a miniature fighting robot. It has lots of different sensors and lots of different things to be able to do lots of different things. It can do line tracking, it can do sensing other robots, and they are adaptable with different formats to be able to produce depending upon how you program it. To give you an idea of what this one is like, we're just going to press the start button on this one, and then we'll get it to start and then sort of kick off to give you an idea of what this robot is actually like. Each of these robots have a 5-second countdown, so that when the heat of the fight starts, press the buttons, both the robots will start simultaneously. This robot is actually sensing for other robots from the infrared detectors on the front end of it, and it's reversing out of the way. It doesn't want to get hurt, it wants to run away. So that gives you an idea of Zumo. As I said, a commercially made and commercially produced robot. But the fun of being able to build robots is to make your own. Here's one I made earlier for our local competition. It consists of, it is 4-wheel drive, so there's 4 motors in here, controlled by 2 motor controllers situated at the back, and controlled right in the middle by an Arduino Nano. Thank you. The battery system is on the other side here, which controls the whole of the robot, drives the system. But the sneaky little thing on this one is that this one actually overdrives these motors. The nice little thing about this as well is it has a detector on the front, so that as the robot is scanning around for different robots, it will actually detect them, and then once it gets into range, the flipper will activate and lift the robot up and out of the way. To enable it to stay on the days, the same as this little robot, it also has the small detectors on the front end. So as soon as the white is actually detected on the days, the robot will actually reverse and then start scanning for it in a different direction. Also, to help with the operation of the robot, there is a battery indicator system on the back, which tells us what the current voltage is. So what we're going to do, we're going to start this robot off and give you an idea of what it's like operating on the days. As you can see, it's quite happily spinning around, looking and scanning for its opponent until it hits the white line and then rotates and then goes in the opposite direction. Going to go for an upgrade on this one now to the third one. Now, you all know what these are. Battery drills, incredibly powerful, lots of torque inside these things. Yeah, it's very, very difficult to hold. So what happens if you actually strip the motor out of one of these, or two of them, and put them into a robot? So, here's one I made earlier. This is Basher. As you can see from the side of here, this is the back end of the battery drill motor, which feeds down here onto the very, very wide sticky wheels. And these two motors are actually sitting back to back on the base of the chassis. Now the battery, the drill motors are 12 volt matched pair. So they run at the same speed and they are operated by these motor controllers. The battery that supplies these motor controllers is rated at 14 volts. So as you can imagine, pumping 14 volts into a 12 volt motor, it's going to overdrive it. Now we use exactly the same control system to control this little robot using an Arduino situated right in the middle of all that wiring. And we have right at the bottom a laser ranger finder which has still got to be utilized. The power of this little one really is quite remarkable. So much so that we have had to regulate it right back. And I would say we are using about 20% of its total power. It really is quite a powerful little robot. So we're just going to put on the base, and as you can see, it is quite slow. But the pushing power is very, very powerful. So, as I said before, we run 4 of these competitions a year. We have the Robotics Club Show and Tell Christmas Do. We run the Science Fair show at the Sports Cage in March. We have our normal competition at Beach Lab, which is in June. And then we normally have the Steampunk Sumo at the Aberystwyth Steampunk Festival in October. So we have about 4 competitions a year. So just to give you an idea of what these little chaps are like, we're going to have a little bit of fun. There's only 3 here at the moment, but we're going to have a little bit of a competition between the 3 of us. So we'll put Pasha in the middle, see what he's capable of doing. We'll put Fernibot onto one side, all ready to go. And then we'll put Zumo in as well. Now, before we start these up, is it complicated to make? Yes and no. You need some design skills. A lot of these are made out of cut acrylic. You can CAD these designs. The majority of these motors are available online at the majority of robotics supply stores. The commercial ones are available online, obviously, as well. You need to do some research. Links for these sort of things, if you needed to find out a little bit more, then it can be done through the Q&A session, or if you email the Robotics Club, then we can help you again in the future. There is, hopefully, to expand this to a much larger competition so that we can take it around different festivals, and then a championship league will be developed and evolved as it goes along. So that gives you an idea of the Sumo's robot side of things, how to build them. And so we'll just have a little bit of fun now. We'll switch to these robots on and we'll see who's going to have a win this afternoon. So, Thomas, are we ready?
Probably.
Right.
3, 2, 1, go. Oh, we've got a cheater. Oh, there we go.
We're having fun with this one. He doesn't want to stop.
Oh. Come here.
Oh, he seems to find the little one. Nope, he's popped back out again. And the little's decided to go. There we go. About time. Better late than never. Will they actually manage to find each other and have a bit of a scrap? Little Fernybot is getting a bit closer.
Oh.
No, this one's actually run out. So we'll pop him back in. Oh, there we go. Having a little bit of a peck then to see what was happening. Fernybot is still going around the outside of the arena looking for the little robots. And there we go. It's just managed to push him out of the arena. Quite effective little robots. A little bit of fun. A little bit of fun and gives you an idea of what sort of things can be done by using second-hand parts. Are they expensive? I would say this one, yes, it is expensive. You can get cheaper versions. This one, I would say, with the control electronics and the motors, possibly about £60. And for this one, well, 2 scrap battery drill motors. The most expensive part of this were the motor controllers. £5 each from China. It's just, it's just a no-brainer. It's good fun. The competitors who take part in it have the enjoyment of actually building these sort of things. Some people prefer the programming side of things, where you can actually program it to do so many different things, like attack instead of defending. So if you ever fancy having a go, keep on looking at the aberystwythrobotics.club website and you'll be able to find out when the next competition is being held. Thank you.
Okay, we're back again, and thank myself for doing that. It is a bit of fun, and we've got Fernybot here. It's an amazing little machine. It's done. It's had about 50 battles. It is quite a battle veteran in that respect. It's 4-wheel drive, and as you can see in that last one, it was actually driven over Zumobot. Yeah, it's good fun. They are reasonably easy to make. You will need some sort of robotic experience. A lot of the information can be picked up online, and you just sort of go from there. The nice thing about it is that they are homemade. Yeah, you can make them at home with simple tools. You don't have to have incredible engineering sort of experience. We are going across to the sort of live Q&As, which are available on the YouTube website. If there's anything there that anybody wants to ask any questions on, then do please give us a shout. We are also, with these things as well, do please have a look on the website and you should be able to find out what's going on. Right, here we go. A little bit, hang on a minute. Let's move this little chappy above out of the way. A little bit of information on what's coming up in our next section. Lots of talks and bits and pieces going on this afternoon. We aren't at, over the shoulder, we aren't at the bandstand today, so we are actually live online. So coming up shortly is ExoMars and what Aberystwyth University's contribution is to that. After Helen, we have got the hobby robots, and this is all, I want to build a robot, what's out there? And we've got Patricia going to give a bit of a talking about that. And we've got one of our younger members of the robotics club
giving a talk and a beginner's presentation as well. And coming up now also later on in the week, because it is Robotics Week and today is Beach Lab Day, during the week we've got lots of things going on as well. Monday evening, I keep on doing this, other hand, come on Steve, we've got an evening with the robotics, and that will also be online. On Wednesday we have a 3D design robotics workshop. 3D printing is coming into its own in quite a force now. If you don't have the experience as far as engineering skills are concerned, but you want to make something, then this will give you a stepping stone as to what you need to do. On Thursday, we've got the electronics workshop. The electronics workshop will give you an idea on what you need to do to put into your robot to get it moving and to get it building and to get it running. On Friday, this is a family pub quiz. All members of the family can come along and join us and have some fun and enjoy the quiz. So if we do have any other people who want to make things with their younger children, I mean, we are all at home in one form or another, and we're looking for other resources and other bits and pieces. Tali has done a lot of work over the last couple of weeks, and she's been doing robot crafts, and the information for that, where you can download all the bits and pieces, is available at, I'm so coordinated here, is all available at roboticsweek.ecs.aber.ac.uk. Also on this is the Aberystwyth Aberobotics.club. So it gives you an idea of what's going on later on this week. So moving on, it gives me great pleasure now to introduce you to Dr. Helen Miles. Helen is one of our colleagues at Aberystwyth University, and Helen is involved with the exciting project which is the ExoMars mission. Helen's research is in the field of computer graphics, virtual environment and visual perception and data visualization. Helen's involved from 2014, working as a PDRA on the Heritage Project, collecting 3D visual digital recordings of Neolithic archaeology sites across Wales. And from 2015, she became a lecturer for the computer science department. Since 2016, it's quite exciting. Helen's been working as part of the university's ExoMars mission, simulating images from the perspective of the PanCam instrument, which is the cameras on top of the ExoMars rover, and it's been led by UCL and MSSL, and developing the processes to work with the images taken by PanCam when it actually lands on Mars in a couple of years' time as part of the next European Mars exploration team. Helen is currently leading the 2.4 million ESF advanced media production project delivered to postgraduate level training programme, supporting Wales's creative industry sectors by training professionals and graduates to exploit new technologies in media production. Helen is absolutely another incredibly talented person that supports the Robotics Club, very interested in engaging with the public and communicating science, and help to plan and run outreach activities. And the aim is to spark an interest in science and computer science. Helen runs the leading group of the advanced group for the Aberystwyth Robotics Club and is the co-developer with Barnes, which is the full-scale ExoMars rover, which I've been involved with as well. It gives me great pleasure to introduce you to Helen. I hope you really enjoy this. This is the information on what Aberystwyth is doing regarding the Mars project.
My name is Helen Miles. I'm a computer scientist working at Aberystwyth University, and part of a small team from the Departments of Physics and Computer Science working on the European Space Agency and Roscosmos ExoMars mission to search for evidence of life on Mars. In this video, I'm going to tell you a little bit about the ExoMars mission and what we're doing as a part of it. ExoMars, short for Exobiology on Mars, is a two-part mission to search for signs of past or present life on Mars. Part 1, the Trace Gas Orbiter, was launched in 2016 and reached a stable orbit around Mars in April 2018. Part 2, the Rosalind Franklin rover and the Kazachok lander platform, is scheduled to launch in 2022. The Rosalind Franklin rover is a six-wheeled rover as big as a car. It's solar-powered and carries a suite of scientific instruments to enable scientists to remotely search for signs of life. Aberystwyth University are part of 3 rover instrument teams. The panoramic camera PanCam, an instrument led by UCL's Millard Space Science Laboratory in Surrey. The infrared spectrometer for ExoMars, ISEM, led by the Russian Academy of Science at the Space Research Institute. And the close-up imager CLUPI, led by the Space Exploration Institute. PanCam is the primary remote sensing camera system on the rover. It will be used to search for places to investigate. PanCam can pan and tilt to look around in all directions and contains 3 individual cameras, 2 wide-angle cameras, WACS, and the high-resolution camera, HRC. The wide-angle cameras are multispectral. The cameras themselves take monochrome images, shades of grey, but in front of each camera is a filter wheel containing 11 different filters, each with a different purpose. Some of them allow us to take colour photographs, while others let us see into the infrared, showing us things our eyes can't see, like minerals which can only be made where there has been water. A good place to search for evidence of life. ExoMars is a huge mission involving many people from all over the world. Aberystwyth University's contributions are developing and manufacturing hardware for PanCam, ISEM and CLUPI, calibrating PanCam and ISEM, helping to develop the processes to use PanCam, modelling and visualising the images produced by PanCam, and developing software to process the real images from PanCam. Calibration is the most important thing we can do with the cameras. Without calibration, we have no scientific measurements.
We have to calibrate camera systems, otherwise the pictures we get are not meaningful in any scientific way. Cameras are never perfect. There's always something that causes distortions in images or colours to come out wrong. So how do we make sure things are right? Well, on Earth we use colour checkers, things like this, or geometric targets that allow us to make sure that that the camera is showing what's really there. So this has 6 different grayscale levels and 18 different colour patches, and each of the grayscale levels is very well characterised along with all the colour ones, so we know exactly what colour each of the patches are. And using that information, and you can look at a picture that the camera's taken, and you can then work out how to adjust it to make sure everything's perfect. Using the measurements that we get from the test targets and clever software, we can turn the images into useful measurements. We took part in a major calibration campaign to learn as much about the cameras as possible. For radiometric calibration, we're trying to understand how the cameras respond to light and to dark. So we take hundreds of photos of a completely plain white background or a completely plain black background. If the background is uniform enough, then this allows us to see all the little features of the camera that are not quite right. So If one pixel is more sensitive than the others, then that'll show up. If one pixel is less sensitive than the others, then that'll show up. Calibration is one of the last things that we do. It doesn't have to be the last thing, but you have to make sure that nothing gets changed on the camera between calibrating it and landing on Mars. So the whole rover is kept very clean and very sterile, and some of the things that we need to calibrate can only be done on the fully assembled rover, so we have to go and work with it. So the calibrations that we do on Earth allow us to work out how the camera responds to light. The calibrations we have to do on Mars are to tell us what the light is like on Mars. So on Earth, light is sort of bluish, so the sky is blue. On Mars, the sky is red, and the light is much sort of redder, so we need to characterise all of that, and we do that by taking calibration measurements when we get there. So this is the calibration target for PanCam, which will be used on the ExoMars rover. It's made of aluminium and stained glass. It provides us with several reference patches, which we know exactly what their colour and sort of reflectance properties are. So this is basically what we will use for getting all the colour measurements on Mars. So these are fiducial markers. They are geometric reference points that will be used on the rover. So we need a few points where we know exactly where they are, and that they're easy to identify, so we can make sure that the camera and the Mars systems are all calibrated correctly. This is the rover inspection mirror. It allows us to see bits of the rover that you couldn't see otherwise. So we can basically use a mirror. It's basically like having a mirror on a stick to look underneath the rover.
After years of development and manufacture, the small items are now all attached to the real rover. Understanding how to use any instrument effectively is really important. Imagine going for an exciting day out with your new camera and only finding out later that all the photos you took were blurry. With your camera not allowed to leave a clean room, it's very tricky to know how to use it. So we've been working on some ways to help. Meet UPI. UPI is the Aberystwyth University PanCam emulator. It's made from off-the-shelf components, is a lot bigger than the real thing, and definitely isn't space qualified. But it produces images which are very similar to those that will come from the real PanCam instrument, and has been made to go into the field. It has travelled with scientists to Mars analogue sites all over the world. It's important for UPI to photograph different kinds of rocks and minerals in different environments, to help scientists understand what they can expect to see from PanCam, and how to make the most of the data that comes back from Mars. The data from UPI have been used to develop processing methods, ways of manipulating the data and combining the data from different filters that highlight particular minerals. UPI has been used in several rover field trials, scenarios which let scientists and engineers practice for what the real mission will be like. A rover emulator is taken to a secret location and looked after by one team, while another team work together in a control room to try to work out where they are and to understand what geology is around them. The team in the control room send instructions to the rover, where to go and what to measure or take images of, and a team in the field provide that data. The two teams can be on different sides of the world, and a field trial can last for several weeks. It takes a long time to do anything when you have limited information. You might have noticed that the rover emulator is not quite like the real thing. The real rover is so complex and expensive, it isn't possible to make a duplicate to go out for field trials. Now this leaves us with a gap in our understanding. How can we be sure that the real rover can see the calibration target, or the rover inspection mirror? The ideal solution would be to use the real rover to take test images before launch, but because of the tight schedule for building the rover, this hasn't been possible. Instead, we can use computer graphics to simulate the views from the cameras, using the same techniques as are used to make images or videos of what the rover will look like, and the same that are used in the film industry. We can look through the eyes of PanCam. This can help us solve some really important problems. Where should PanCam be pointing to get the best data from the calibration target or the rover inspection mirror? Can PanCam see all of the fiducial markers clearly? The rover is able to pick up core samples using a drill on the front. Can PanCam see the core before the drawer pulls it into the internal laboratory? Using this simulation system together with UPI allows us to better understand the output of the camera system. So now we have calibration measurements for individual camera properties and an understanding of how to use the PanCam system. But once we land on Mars, we need to use all of this information to ensure that the images used for scientific analysis are as accurate and free as artifacts as possible. Some pixels won't give the most accurate data because of the way current flows in the sensor, the way lenses collect light, pre-existing imperfections in the sensor, and some pixels will become damaged by X-rays or cosmic rays during the mission. The calibration done before launch will help us to mitigate some of these points, and the continuous calibration during the mission will help us to update our information and track changes to each pixel over time. By creating software to process each pixel of the image according to its own specific needs, we will be able to create higher quality data for scientists to use. But there is a complication. Mars is a very dusty planet, and once we arrive, the rover, camera, calibration target will all slowly start to get covered with dust. We need to learn more about the optical properties of dust on Mars and how the light and dust will change what cameras will see. This is our next challenge. This is ongoing work, and we're still in the process of analysing the calibration data and developing the algorithms for the software. Once it is complete and the mission starts, any images from PanCam will go through this software to ensure data of the highest possible quality before being used for scientific analysis. So what's next for the ExoMars mission? Launch is scheduled for 2022, which would see the rover land mid-2023. After that, the mission aims for at least 218 sols, Martian days, of science. But the NASA Opportunity rover was expected to last 90 sols and continue to run for 15 years. Hopefully ExoMars will have similar success. The ExoMars mission involves a lot of people and is a very collaborative project. Our work would not be possible without others. We want to give special thanks to the late Professor Dave Barnes, who set this all in motion and is greatly missed. To find out more about our work, visit exomars.wales or exomars.cymru. To learn more about the ExoMars mission, visit www.esa.int.
Okay, and welcome back to Beach Lab Live, and thank you, Helen, ever so much for a wonderful video. It, absolutely fabulous, really, really nice background information on ExoMars and what Aberystwyth University is doing towards the next Mars mission, which is really, really exciting. So, Helen, the Q&A box has exploded. Lots of questions coming in, so I promise I'll try and keep it as simple and as easy as we can. Helen, as we know, there's evidence of tornadoes or dust devils on the surface of Mars and huge amounts of dust. How are you going to be able to replicate that, to be able to test it?
Yeah, so it's going to be quite difficult to work out in advance what kind of dust we're going to experience where ExoMars is going to land. So dust, we know there are dust storms on Mars. We know that there are seasons where there are dust storms, and we know that dust is different in the different places that rovers have already landed. Because ExoMars is going somewhere that no other rover has gone before, we think that the dust will be a little bit different again. So we don't know exactly what to expect, but we do have TGO to help us flying over and taking sort of remote sensing data that is going to help us work out in advance what kind of dust we're going to experience. But what we're going to do at Aberystwyth University is we're actually going to start doing tests with analog dust. So that is dust where we know the chemical properties roughly of the sand and the dust that we might experience on Mars, and we can come up with basically something that simulates it. So something that is like Martian dust and very, very similar, should behave in a similar way. So we can actually put a calibration target in a chamber and blow some dust around and basically see how it lands on it. And after that, measure how the light has changed in terms of what we can see with the cameras. And we can do this over and over again, and we can do different amounts and different levels of dust and see what things change.
I've had a question from Fred, and can some aspects of the calibration actually be changed during landing at all due to this dust storms possibly?
Yeah, so the calibration target is going to change quite a lot over time, and this is something that NASA have already seen with their calibration targets and their rovers. As we travel on Mars, we'll find that we slowly build up layers of dust because it's just in the air, it just kind of blows around. So even if there isn't a sort of significant dust storms, we will have to take account of that when we try and calibrate. And that's why we want to find out what will happen when dust actually lands on the calibration target. We do also have dust clearing events, they're called. So when you get a really, really strong wind, it might actually blow the dust away, which is very, very handy. So we're going to have to keep track of how things change over time. And that's why calibration before and after is really important. And it's not after as in it doesn't happen once. It will happen every day, possibly several times a day. Because actually as the light moves around above the rover, we will see slightly different things. And so every time we take a set of photos, we will need to have an equivalent photo of the calibration target so that we can actually turn the photos of Mars into actual scientific measurements.
Helen, it's lovely to see you got a fantastic little model of ExoMars there. It looks absolutely superb. We know we've done it all in virtual reality. We've done so much other bits and pieces with Mars. One question that's come in, would you actually like to visit there in person?
No.
Nope.
I don't think it would be a very nice place to visit, really. It's not the most friendly in terms of sort of a place for life at the moment. So, if we eventually do go to Mars, it's not going... The air isn't okay for humans. There's a lot of UV. It's not got an atmosphere in the same way that the Earth does. So it's just not set up for life for us at the moment. So we would have to make some very, very significant efforts to actually making places for us to be. So
we won't be going there on holiday, will we? I'm sorry about that. We won't be going there on holiday, will we? No. A quick question that's just come in now from Neil. Does the calibration target fade with time as well as becoming dusty?
That's a good question. It shouldn't. So the calibration target has been made from stained glass, and we know that stained glass is really resistant to changing colour under UV light because we have really, really beautiful, very old stained glass windows all around the world that have been baked under bright sun for a long time, and the colours haven't changed, the colours haven't saturated. So that is exactly the reason that we're using stained glass for the calibration target. So even though Mars has a much stronger UV actually hitting the surface, it shouldn't change the colour of the calibration target at all.
Brilliant. And what sort of life are we looking for on Mars? Are we looking for life?
Yeah, that's a really good question again. So the sort of what we might actually find on Mars is obviously not going to be life like we have on Earth. So that's the most important thing to realise, is we're not expecting to go and find living creatures. We think that Mars was a very, very long time ago, like the Earth was when life first started to form. And we're talking about chemical reactions here. So what we would hope to find would be basically chemical biomarkers, so amino acids and really, really basic indicators that there might have been some kind of life. We don't necessarily expect to find something living there now, but we think that once Mars might have been in a similar situation to Earth was a very long time ago.
Brilliant. Well, thank you, Helen, ever so much for your contribution towards the Robotics Club, Beach Lab, and ExoMars. Absolutely, really exciting. And we're looking at seeing the ExoMars launching now shortly, and hopefully we'll have a successful landing and roaming around the surface of Mars. So yeah, really sort of exciting times ahead, and thank you ever so much for that. Really enjoyed it. Thank you ever so much, and we'll look forward to seeing you again soon. Good. Okay, so we're back at Beach Lab. We're not at our usual annual place. We are online, and we're going out across the internet. You've seen a whole range of robots which have been available and which have been made by some very talented engineers. And so you want to get into robotics. How do you do that? Yeah, you don't quite have the skills, but you can learn them. But, you know, I want to buy one. How can I buy one? Where can I buy one? How much are they? There are skills which you can get online. There are skills which you can learn through the club. There are other opportunities and bits and pieces available, like the competitions that we also run. So what we're going to do now is we're going to go across to Patricia shortly, and she's going to go through a range of robots that are available commercially that you can either buy and work out how you'd actually develop them to be able to use them in a day-to-day environment. Patricia has got a lot of experience within robotics, and she is actually involved in sorting out bits and pieces with our beginners club. So it's a case of a cross to Patricia for that.
Hello everyone, and thank you for joining us for this year's online Beach Lab as part of Robotics Week, which of course has moved online this year. Today for this particular session, I'd like to introduce a range of different small robots that we use as part of the Robotics Club and for outreach activities, but are also suitable if you're interested in having a go at home with some introduction to robots. So I'll be looking at a range of robots laid out here in front of me. I'll show you them as we go, ranging from around sort of £20–30 all the way up to the more expensive robots at about £550. But before I start, I would like to give a dedication of this session to a dear friend who unfortunately recently passed away. He's previously helped with the organisation of running of Robotics Week and a lot of outreach from the university, and a lot of you will probably have known Martin Nels, but he really enjoyed these activities previously, and I'm sure he would have enjoyed it again if he was able to join this year, but unfortunately he's no longer with us. So I'd like to dedicate this to him, and I hope you enjoy it as much as he would have done had he been able to attend. So I'd like to introduce a range of different robots I've got here in front of me. So this here is a BBC microbit. It's actually, if I take this out a moment and just to show you. This is a microbit microcontroller. And there's the back of it. And you've got a couple of little connectors there on top. It's a robot designed by BBC for actually educational purposes within school, getting kids into programming. And it's a very nice, cheap little microcontroller. You can get this on its own, and you can do a whole range of different things today. But what I'm going to show specifically is this chassis that you can get to go with it. So this is a nice little two-wheel robot chassis, which the microbit slots nicely into there. And it's got a range of different sensors built into it. So it's got an infrared sensor on the front for checking how far away things are. And it's got a couple of line following sensors on there. I don't know if you can quite see those there, but there's a couple of sensors there. And there's various different lights, and you can get some other sensors on there. It comes with an ultrasound sensor for a bit more distance ranging finding, but I haven't got that connected at the moment. It's not something I'm currently using for this particular configuration. But there's a whole range of things that you can do with that, and I'll show you that robot running shortly. It's a very nice little starter robot, and I'll also have a look at how we can go about programming this robot and another robot I've got in front of me, because it's very nice and simple, easy to get started with. The next robot I've got here is perhaps one that might be more familiar with a lot of people. This is Lego Mindstorm. This is actually the EV3 version. We use both this version and its predecessor, the NXT, for a lot of our outreach activities, so going out into schools. And a lot of you will probably have had a chance to play around with these in both Sumo and maze navigation at previous Beach Lab events. So this is the EV3. It obviously comes as Lego large kits, and you can rebuild them in a whole range of different designs. They come with quite a lot of different sensors. At the moment, this has only got a couple of sensors attached onto it. There's an infrared that can be used for range finding at the top, and at the bottom we've got a colour sensor there that's currently set up for line following, which gives you a hint as to what some of these robots will be doing shortly. So it's a very flexible, very versatile robot, and it's very nice and robust, which is particularly important when you're going out and doing outreach, and of course with young children. Building up from there, the next robot I've got is a slightly more sophisticated robot. So this is actually an Elegoo robot car. There's various different models, and these come as kits as well that you can actually buy. This particular one, unlike the others, is a 4-wheel robot. And on the top, we've actually got, I don't know how well you'll be able to see it there, but there's an Arduino board, and on top of that board, there's another board for connecting various components together. So at the front, we've got an ultrasound sensor. We've also got an infrared beacon on there for using a remote control with it. But underneath, we've got, in this case, 3 line following sensors. So if I bring that a bit closer, you might be able to see 3 little sensors there, and we can actually calibrate the sensitivity of those as well using this particular variable resistor. Interestingly, the ultrasound on the front is actually mounted on a servo, so it can turn around. So what we can actually do with things like this is quite sophisticated maze navigation, where it drives forward a bit, it turns to have a look around, look to see which direction is safe to move in, and then it can actually turn and carry on in that direction. Being an Arduino, it's slightly more sophisticated on the programming side, so I won't worry too much about the programming on that, but I will show you the programming of the Lego Mindstorm, and it's pretty much the same for Microbit. Those 3 robots have essentially what we call microcontrollers, so when you turn them on, they all run a single program, and they will keep running that program until you actually replace it, until you change the program that's loaded onto them. And actually, before we go any further, I think I'll show you a video of those 3 robots in operation. So I'm actually going to cheat slightly here. I pre-recorded these because robot demos never go to plan. So please bear with me whilst I just share my screen and show these 3 robots doing a line following activity. I should say that the line I've got them following is slightly more challenging than the usual line we would get children to follow as part of an outreach activity, but it shows some of the ways in which they operate. So we're going to start off with the Elegoo robot, the most complicated of the 3, and set that running. We can see it's actually moving forward and checking for the line. I'll say it's a bit more sharp on the corners, this one, than we would normally go for. You would normally go for quite a nice, gentle line following activity. And this robot actually cheats ever so slightly, doesn't quite make it to the end before turning and coming back again. But this robot would just keep going back and forth continually. It's not going to stop, it's just going to keep looking for a line and keep trying to find it. So it would turn around at that point and carry on. Next we have the Lego. So same sort of idea. And what you'll see is that it's very good at following lines that turn to the left, but it struggles slightly more when it goes to the left. And that's actually because of the algorithm, if you like, for how it's following the line. It's only got a single sensor there at the front, and even with the Elegoo robot, it will turn in a particular direction when it loses the line to see if it can find it, and it will keep turning a particular distance. If you still can't find it, it will then stop and turn back the other way. Now that direction is programmed by me to be to the left. I could have set it to the right. In this case, I decided to set it to the left. It actually works slightly better with this line, so that's partly why I chose to turn to the left. And so with the line, if it loses the line to the left, it will find it quite quickly again. But when it's to the right, you have to keep checking in both directions before it's able to pick it up. There's some refinement you could do on the program in order to help it follow the line a bit better. But generally, it does a reasonable job. It made it all the way to the end there, and it will actually follow it all the way back to the end, to the starting point. But it will take its time to get there, particularly on that curve. So I'll jump on to the next robot, the final one, and this one I have to say is my favourite of the three robots. It's speedy, it's efficient, and you can just see it zooming down the line there as it goes. Same sort of principle, that it's scanning in both directions to find the line, but it's actually quite quick and speedy at doing it. Very accurate and very reliable, actually. And one of the interesting things about these robots is the calibration for, say, the Elegoo robot. You actually have to tune the sensor. It gives you quite a bit of flexibility for tuning the sensor. Similarly with the Mindstorm, you can tune the setting so it picks up just what you want. You'll notice the flooring that I've got there, it's got some quite dark patches on it as well. And so those sometimes cause problems for the other two robots veering off and following the flooring rather than the line I wanted it to follow. But the Elegoo actually, so the microbit was really quite precise. It was very well tuned without any extra work. So very quick, very easy to get going. So what I'd like to quickly do is actually show you the program that we used, or a starting program for getting a robot to follow a line that would work with both the Lego Mindstorm and with the microbit, essentially. So I'm going to share a different screen now, hopefully. And this is a setup for the Lego Mindstorm, so it's one of the programming environments. They have two different programming environments that you can use. This is one of the more recent ones that they've developed, but there's also more of a block-based engineering type environment, if you like. But what we can see here is a simulation of the Lego brick on the left. And as we build up a program, it will actually connect motors and sensors to the various ports that we've got. So we can see the two driving motors for the two wheels up at the top. And this is the light sensor that we're using. And actually what we can do is, as I change the light sensor here, you can see that the numbers up at the top for the speeds of the two motors start to change. And if I take it in the other direction, you can see that they're moving in different directions as well. And when we're programming a microcontroller, essentially it's executing a single continuous loop. It's repeating the same action over and over. And this is how we get the scanning behavior. So essentially in each loop, when it's operating, there's two things that we need to do. We need to read the current sensor, see if it's actually detecting a line or not. If it is detecting a line, great, we want to just drive forward. If it's not detecting a line, then we want to change direction. Now, this very simple program essentially does that for us. So it's got the color sensor here. It's looking to see if it's with a particular threshold, so you can adjust how light or dark it needs to be in order to distinguish the line from the background. If it doesn't detect the line, then it's actually going to set the wheels turning in opposite directions. And so then it will actually turn on the spot. In this case, it will just keep turning until it refines the line. So if you've got a straight line, that means it will end up turning around and going back the way it came. If you've got a nice circle, so if you're going around the outside of a circle, then you can actually do that very nicely and carry on going around the outside of a circle until you turn it around to go in the opposite direction on the circle, and it will actually insist on going back the way it prefers to go. So sometimes it's actually, you need to put in a bit more effort there to try and stop it from going too far, and so you do end up with a scanning behaviour. But most of the time, this actually works quite nicely for a simple robot. And of course, if it does find the line, then you can just go straight forward. Now you'll actually notice I've put a slight offset in there between the two wheels, so you'll actually keep veering off in the other direction. But then it will then adjust back when it loses the line, so that can help to compensate for a gently bending line, not perhaps the line I was showing just there. And you can actually build up these. They're very easy to just add more sensors to them. There's motors, different motors as well that you can add there, and it's very easy to use. And if you want to take it a bit further, then you have got the option with this one, for example, of looking at that in the JavaScript, so going to the next level of programming if you like. Okay, so that's, stop showing that one for a moment. That's the first three robots that I've got there. Moving on from microcontroller-based robots, we've got some slightly more sophisticated robots. So some of you may have heard of the Raspberry Pi. I've got one here just in front of me. It's actually got a pan-tilt camera mounted on top of it, but the bottom board, which you can perhaps see there, is a Raspberry Pi 4. They're on the 4th generation of these computers, and they are actually miniature computers. So this particular one has got 2 gigabytes of RAM. It's got 1.5 gigahertz processor. It's got wireless LAN on it, Bluetooth. It's also got various USBs and Ethernet connectors there. And one of the changes with this particular version is they've got some micro HDMI connectors. So you can plug in an external monitor, you can plug in a keyboard and mouse, but they can also operate without any external peripherals. And it is literally a small computer. You can run an operating system on it. Currently it's got a flavour of Linux running on there. And on top of that, you can do a whole range of different things with Raspberry Pis. But you can also start to use them to program and build up robots. Now this one at the moment is configured with a pan tilt servo on top, so we've actually got a 2-axis servo there, and so you can do some panning and tilting. And what you may be able to see there in the middle, there's actually a Pi camera mounted on there as well. So with this, we can actually program up the camera to be able to track objects around, and I'll show you that running in a moment. And just for a bit of fun as much as anything else, normally this would be mounted on top of the Pi tilt camera as a light, so you can actually shine a light on what it is that you're looking at. This is a NeoPixel. You can actually daisy chain these together, so you can have multiple in a line, and they can be directly connected, or in this case I've got quite a long wire allowing me to move it around and show you. I'm going to try to very quickly show that this is actually really bright, so you won't be able to see a huge amount of colour at full brightness, but if I quickly run this up, you'll get an idea of how bright it can be, to show some of the different range of colours that it can get. I mean, that is really bright at full brightness. I mean, I would not want to be looking directly at that right now, because it is actually quite dazzlingly bright. So I'll take that out of the way a moment. And as I say, what we can do with that is actually use the camera to track an object. And so I've got a little program set up that I will try and show you now. So what I've got is I've set up the NeoPixel to a very pale, lowest level of green light that it can. So what we can see is we can actually detect that, if I get it away from the window, which is far too bright at the moment, and we should be able to detect the green light, and hopefully we can start to see if I can get this into position that is able to track and move the servos. around. So that's one example of being able to use that. Now, clearly at the moment this is actually essentially a static demo, so although it can move the pan tilt around, it's not necessarily able to drive around itself. And for most robot applications, we would like that to be able to drive around. So what we can do is we can actually connect the Raspberry Pi to an Arduino. So potentially, if I show you now, we could actually connect the Raspberry Pi to our Elegoo robot. We can use the USB out from the Raspberry Pi and feed into the Elegoo, so we can actually send commands, use the camera there to be able to control and drive around the Elegoo robot. But rather than modifying the Elegoo that we've got there, we've actually got our final robot. I haven't actually got this one up and running at the moment, but I can show you. This is actually quite a complex, sort of the top end, if you like, of the hobby scale robots. It's called Turtlebot. And if I try and bring this a bit closer, what we might be able to see is some of the things going on. So we've got in there a Raspberry Pi. On the front, we've got a Raspberry Pi camera. And actually on the level below, we have an Arduino on there as well. So the Raspberry Pi is processing the input from the camera. It's also running various other applications on there. On the top, you may be able to see this is actually a laser scanner that's able to detect obstacles at quite a distance. So it's able to construct maps of its environment, for example. It's able to see objects in the environment. And it's able to then actually process that information and then provide commands to the Arduino layer, which will then drive the motors to drive the robot around. This laser scanner that we've got on the top, for any of you that perhaps had a look at robot vacuum cleaners, it's interesting to think about how different robot vacuum cleaners actually operate as well. So if you've looked at something like the Roomba, for example, that actually uses a random navigation with bump sensors to just gradually explore. When it bumps into something, it will change direction and it'll keep bumping around. But other examples, such as the Neato robot vacuum cleaners, use these laser scanners to construct maps and build up a model of your living room, of your downstairs, and then plan a path which enables them to explore the entire area as visually as possible, and travel in nice straight lines back and forth. And these laser scanners are essentially what it's using in the top there in order to be able to do that. So that's essentially what I wanted to cover there. I hope you found that informative, and I'll now be taking some questions if you've got any questions about any of these robots. I have to say, I do love these little microbits. They're amazingly flexible for what you can do with them. Very easy to program, very easy to get started with, and there's lots of different chassis as well you can put them in, but you don't actually need the chassis. There's lots of things you can do without the chassis. So I would certainly recommend everybody has a go at playing with one of those. Others are available, of course. So thank you very much. I hope you enjoyed that, and hope to see you all soon. Hello again. I'd like to share with you a short presentation that's been put together by one of the members of our Aberystwyth Robotics Club, specifically one of the beginner members, showing some of the things that he's been working on as part of the club. So I shall share my screen with you. So since the lockdown, we had to obviously suspend the club sessions, but we switched to providing some online activities. And the first of these was a 3D CAD design. This will be part of the basis for one of the workshops later on in the week. Specifically on Wednesday, we're running a Tinkercad workshop. And introducing the club to this online platform, he was able to produce this particular rocket design, which I think is a very nice rocket, and hopefully will fly into space one day, but perhaps not just yet. Some very nice animations. He's also, as part of the online activities, been working on learning how to program and make games in Scratch. And he's got 2 examples here that he'd like to share with us of his favourite projects. So I'm going to quickly switch over to those and show you those running. I do apologise for my skill level in these games, but I think he's done a very good job of these. So the first is a space race that he's put together. He's obviously been developing this and continuing to work on it since the Scratch workshops provided through the club. I'm going to have a go at this. As I say, I'm going to go with easy because I know I'm actually not very good at games. And I'm going to try and beat this robot. And it's very, very close. It's going to be very, very, very close. But unfortunately, I think I need a bit more practice on that game, but it looks like a very nice game, and it's got a range of different options now. There's a time trial, and there's also an obstacle course, and if I really wanted to go for it, there's a hard option, but I don't think I'm quite ready for that just yet. The other game that he's put together, and completely on its own, I have to say, we provide the starting material, and we really love to see where the members of the club then take that. And Malay has certainly excelled in this. He's done a really good job. This is the Cool Cat, the platformer. And so I guess here we need to try and reach the purple squares whilst without falling down. So let's see what we can do here. So I can control the cat, a very cool looking cat indeed. I can jump up. So let's see if we can, there we go, on to the next platform, and got to the first level. There's multiple levels here. And now we have red lines that we need to avoid as well. So let's see what we can do to avoid these red lines. I say my skill level in games is really not that good. Ooh. Some nice jumping around. There we go. Level 3, and I wonder how many levels there are. Well, that's a challenge. Let's see if we can. I did manage this one in a practice run. There we go. See if I can jump over the red line. Yay! Just need it. And the levels do keep going. I won't say where I got up to. I should say if you hit the red lines, then you do get reset back to the beginning. So it's not that I'm cheating here. Oh, yep, definitely getting harder. But yes, do feel free to try out those games. They look very fun. Okay, so let's go back to the slides. So those are a couple of Scratch games that he put together, and he's really taken the ideas from the club that we presented there and flown with them quite literally. Before the lockdown, we had the opportunity to provide Arduinos to the members of the club and give them opportunities to build them. One of those was using the Eliga robot, so we've got the chance to build that up. And there's some other opportunities, and he's perhaps referring to those projects that he was working on. But there's loads of things that you can do with an Arduino. You can connect all kinds of sensors, motors, lights, and you can do lots of fun things with those. I'd say it's not got one at home, but perhaps with the electronics workshop, which does include an opportunity to try a simulated Arduino, and that's running on Thursday this week. Do sign up for that. To have a chance to play around with a virtual Arduino, try plugging different things in quite safely without releasing the magic electrical smoke that sometimes happens with electronics. Moving on. One of the first activities we did with the club was actually getting them to learn how to solder circuits nice and safely. So it was actually on the run up to Christmas as well. So we helped them produce these lovely Christmas trees with flashing LED lights on them. The circuit board was pre-printed for them. The components were all laid out. It was simply a case of putting the LEDs, the transistors, the capacitors and the resistors in the right places and being able to solder those on. And he did a very good job of his Christmas tree, and I'm sure it was a lovely decoration at Christmas time as well. Certainly worked very well at the end. Very nice job there. If you are interested in the club at all or any of these workshops, then I should say that you can go to the Aberystwyth Robotics Club website. You can find that at aberrobotics.club. And from there, although you'd normally need to sign up to be able to submit an application form to join the club, it is actually possible to register temporarily to be able to access some of the online workshops that we're currently doing. There is a registration page just here. You don't need the invite code to actually be able to register, but you should be able to register for online workshops that we've currently got available. But as I say, on Wednesday and Thursday this week, we will be running the Tinkercad design and circuits workshops, so that will certainly give you a taster of some of the things that we can at least offer whilst in lockdown, and hopefully then that'll give you a taster for coming and joining the club when we next are able to reopen. So thank you very much. I should stop the share there and I hope you enjoy the rest of the day.
Well, lovely. Thank you for that, Patricia. It's great. Hello up there.
Hello.
And we're back with Dr. Patricia Shaw live at Beach Lab. And it's wonderful to see the little creations that everybody is coming in with. And that presentation was done by a 12-year-old. It's wonderful to see the creativity and the enthusiasm that some of these young children have. And isn't it wonderful to see, where you think that where these kids are going to be when they're our age? It's absolutely fabulous and quite inspirational. So we got a couple of questions coming in on the live feed, and so if we can sort of go through these, Patricia, if that's okay with you. So we got a question from Helen. Which one of the robotics kits do you think would be the best for a first-time robotier?
So for somebody who's really just starting out, then actually something that's quite straightforward, quite flexible, quite robust as well, that tends to be quite useful. I would probably recommend something like the Microbit. So it's a really nice, easy to use, small computer, not too costly. So if you get it and actually don't quite take to it, then it's not a huge expenditure. But there's a lot of resources out there for all kinds of different projects to get you started, get you going, and to try things out. You don't have to get the robot chassis on its own together. You can just get the Microbit itself, and there's still a lot that you can do with this little board itself. And I believe a lot of schools have got sets of these, so do ask at your schools if you want to try one out.
Brilliant. And there's another question that's come in with that as well, is what types of sensors would you recommend to go with that particular type of robot?
So with this particular robot, the kit that it came with, obviously it's got the line following sensors on there. It also comes with an ultrasound, although it's not currently connected. You can actually add other sensors onto there. It really depends on what it is you want to do. So you could have it, you could attach a microphone onto there to get it to be able to follow sounds. There's light sensors on there. You could control it with a remote control. So it just depends on what you want to have a play around with, but do start off with the basics that it comes with before trying to add on extras.
Lovely. And what sort of prices are we talking about for these types of robots, Patricia?
So for this one, you can get the Microbit and the chassis for about £40. The Microbit on its own you can get for about £20. The next one up would be the Elegoo robot, which is comes as a kit that you can build, and that's about £60–65. And then building on from that is starting to get slightly more expensive. So if you really want to go for it, you could go for the Raspberry Pi, and that's the basic Pi, a small computer you can get for, I think it's around about £50, but then building on top of that with extra components, the camera, there's quite a nice extension to that. So it does gradually increase in cost and complexity as you go up.
Brilliant. And where can we get them from?
Pretty much any major online retailer. I'm sure you can think of a few, but if you just do a search for those, then you'll very quickly find them. There are increasingly some high street stores that are starting to stock them as well, but certainly have a look online and you'll very quickly come across various retailers for them.
Brilliant. And of course we have, as a club, lots of tutorials available online to be able to, for people who are beginners, want to be able to try and learn on how to program. So we've actually done a whole load of robotic workshops that will allow people to do that, which is wonderful.
Yeah, so using the Elegoo robots, we have got a whole series of workshops that take you through how to drive the robot around, how to read from the sensors, how to actually integrate the information from the sensors to be able to even navigate a maze, which is quite a complex challenge in its own right. So there are the workshops there, and you can join a club. And the club really aims at taking you through step by step, building up the skills to not only be able to program, but build, design, solder the robots all the way through. And then we'd just love to see where the kids take those ideas.
We've both been very fortunate in expanding this in quite an international project recently. And do you want to tell us a little bit about that?
Yes, so based on the model of the Aberystwyth Robotics Club, we're really looking at international development and helping people in countries that perhaps don't have access to the technology, don't have the opportunities that we have here in this country to be able to develop the sort of computational thinking and robotic skills. So recently we have been running a project in Iraq to help the children there really get to grips with some of the technology, learn some of those skills, and have opportunities to work as part of a team as well to build up some of the team building skills. And that has been really successful so far. Unfortunately, it's on hold at the moment, but we are hoping to resume that as soon as we can.
Brilliant. Thank you, Patricia, ever so much for that. Thank you for joining us again live on Beach Lab, and we look forward to seeing you again with some more robots very, very soon.
Thank you.
See you soon. Thank you. Okay, so we're going to go back on to a little bit of the program as far as what's happening for the rest of the session this afternoon. We have got I've got to stop doing this. Let's try the other hand. We've got coming up Sailbot. We've got the Sailbot team. We've got autonomous driving in Welsh upland areas, and we've got Hexagon Cupboard. I'm looking forward to seeing that one as well. And then as far as the rest of the week is concerned, we've got an evening of robotics on Monday night, and that is going to be led by two of our research scientists who will be talking about the different aspects of robotics. On Wednesday, we've got 3D CAD design workshop. So if you wanted to get into starting how to design your own robot, doesn't matter what age group you are, you can get involved with it. Thursday, we've got the electronics workshop, similar design sort of thing. So if you've got a robot, it could be a cardboard box which you want to put some wheels on, then you can do that as well. Friday, we've got the robotic pub quiz. That's a family one, and you can all sort of get involved with that as appropriate. And then all week as well, if you are homeschool learning or you've got youngsters who are getting a little bit bored during these times, then there is Robot Crafts, and you can download worksheets and workshops so that you can help and keep the children entertained during this time. We have also had some feedback off some of the on the live chat, some of the people actually asking that they want to be involved and would like to make a sumo robot as well, and details for that are also available through the Robotics Club website at robotics.club, and if you put /sumo, it'll come to the rules and build regulations as far as that, or you can get it through the links actually here at the moment. So we're going to move on to the next presentation now. As I said before, we were all supposed to be actually live here at this venue today. Unfortunately, due to circumstances, we are live online instead. And but so far, we've had everything which has been on the land or on the promenade or
fighting or doing bits and pieces. It's all land-based. So now we're going to do it slightly different. On the other hand, we're going to go into the water. Yeah, the water, it's down here, it's the wet stuff. Yeah, we're going to go in the water, and I want to introduce you to Colin Soze. Colin has been involved with robotic sailing boats for quite a number of years and is instrumental in the establishment of the Sailbot team. Colin is a research software engineer for the Supercomputing Wales project and helps research staff at Aberystwyth convert existing software or write new software to run on supercomputers located in Cardiff, Swansea and Bangor. And Colin is able to help researchers in any department to deal with data analysis and big data problems that Supercomputer Wales can be involved with. Colin had his PhD in working with sailboats and has obviously later applied this software and applications to the working with drones. He's responsible for the Sailbot team, who have had international success over the last few years, which is quite exciting. And the sailboats negotiate autonomously over a predetermined course. And so it gives me great pleasure to change tack slightly, so to say, and go across to Colin's presentation on sailbots.
Hello and welcome to this talk on robotic sailing. My name's Colin Soze, and for many years I've worked on robotic sailing boats at Aberystwyth University in the Intelligent Robotics group. So you might be wondering why we'd like to have robotic sailing boats, and the main reason for them is not to just sail people for pleasure, but to do what we call in robotics the 3Ds, tasks that are dull, dirty or dangerous. And this might mean things like oceanographic sensing, where we send a robot out into the sea to measure something like the temperature or the salinity or the depth of the water for a very long period of time, or in places where it's very difficult to send people to. From a robotics research point of view, we also use these kind of robots for research into how we can get robots to perform on their own for long term, because unlike most robots, there's no one there to press a reset switch if something goes wrong or to turn it on and off again. The robot's got to be very, very independent. We've been building these robots in Aberystwyth for many years, and our first one was called ARU, the Autonomous Robot for Ocean Observation, which we built in 2004. And I'll just show you a short video of that robot. The sail on it is a wing sail instead of a traditional fabric sail, because these are more resilient, harder to break, and they work very well in very light winds as well, because they don't lose their shape as the wind drops. And this one is actually made out of a piece of aluminium from an old London bus. Now this boat had some very simple sensors. On top of the sail is a wind vane to measure which way the wind is coming from, so it knows how to set its sail. And there is a compass to tell it which way it is pointing. There actually isn't any kind of GPS navigation in there, so all it can do is sail on a fixed compass heading. And what it's done in this video is it's sailed out for a minute or two on a given heading, and then it flips around and sails itself back to the shore. And it should flip around any minute. Actually, I think it's heading back there because I see the red bit at the front, and that's the front of the boat. Now, after the success of that boat, we got some money to build a much bigger, better boat, and this boat was called Beagle B, named after the Beagle 2 Mars probe that was going on at the same time. And this is a 3.5 metre long disabled sailor's hull that's been adapted for robotic sailing. So normally the sailor would sit right down in the middle of the hull facing forwards, and they would control the traditional sail, but here we've changed it for another wing sail. This time it's made of carbon fibre because aluminium would be too heavy on a boat this size. And we've got a more elaborate sensor setup. So on top of the mast is an ultrasonic wind sensor that can sense the wind direction without any moving parts. It's also very, very good at picking up very light winds. There's a GPS on the deck for knowing where it is in the world, a very good magnetic compass. There's a satellite modem as well, so we can transmit data from it and receive messages anywhere in the world as well. And we also have a water quality monitoring device that can be put in it, so it can actually give us some measurements about the sea that it's sailing through. So the device for measuring the water quality is known as a sonde. This is a device that measures 5 different parameters. So it can measure how much oxygen is dissolved in the water, how much chlorophyll from plant life there is in the water, the total amount of sort of dissolved solids, so how clear the water looks, the temperature of the water, and the amount of salt or its salinity. And first we tried using a pump, which is this little red thing here, to pump water into the chamber, which is at the end here, that does all the sensing. We found that didn't work as well as we'd hoped, so in the end we just dragged this behind the boat. And the map on the right shows us dragging it around Cardiff Bay, where we measured the amount of dissolved oxygen in the water. We then got involved in a competition to build boats to race across the Atlantic called the Microtransat Challenge, and we built a much more traditional boat for that. This is a boat based on a topper-taz dinghy that we called Pinta, named after one of Columbus's ships that crossed the Atlantic. And here in this video it's sailing at a competition we had in Austria on a big lake. Now this uses a modified tiller pilot to steer itself, so this is something you'd use as an autopilot on a big boat, and it's the black arm at the back. And apart from that, the electronics are pretty much the same as what we used in Beagle B, as we'd already shown them to work fairly well. It did gain some solar panels later on, which aren't shown in this video, but you'll see those on the next video. So the route we were going to take to get across the Atlantic was going to take us from the west coast of Ireland, down south past Portugal, past Madeira, the Canary Islands, down to the Cape Verde Islands, and then across to Martinique and St. Lucia in the Caribbean. And the reason we have to go this way is this is the way the prevailing winds go. Going through the middle, you get a big calm in the middle where you don't get much wind. Now we also have people who go the other way round and start from North America and come across to Europe. Most of them go from Newfoundland and Canada, which is the closest place they can go from, to Ireland. And although it's a shorter distance, the weather tends to be a lot worse on that route, and you can get icebergs a lot of the year. The Titanic sank somewhere around here, I think, from an iceberg that it hit. And here is a video of us launching Pinta in 2010 off the west coast of Ireland. It was a very rough day, as you'll see from the video. We all felt quite seasick, but the robot was quite happy to sail in these kind of conditions. It's not the sort of day that you would ever have taken out a boat that size on your own voluntarily. So the route that Pinta took, we started on this left hand side, shows more detail, from Valentia Island, and we sailed southwest. We were aiming for this waypoint over here marked waypoint 1, but things didn't quite go according to plan because there's a very strong storm system that started coming in, and we were hoping to get launched ahead of it but didn't quite get there in time. So we never quite made it up to waypoint 1, and then we think something broke and the boat started heading south again, and we got a message here that the system inside had rebooted itself, and we think that might have been water getting into the electronics box. And it kept going south, and then it got to down here, and after 49 hours of sailing we got the last message from the satellite tracking system. But we had a backup tracker that worked completely on its own, running off its own battery, and that kept going for another 2 weeks. And that then showed that we turned around and headed north, and the boat sailed quite nicely to begin with, and then started to slow down and go around in a lot more circles, and we think at that point the sail probably got destroyed. And eventually it just stopped sending us messages, and we never found it, unfortunately. But since then there have been 31 attempts to do the Microtransat, and one of them has been successful, and that's this purple one here called SB Met from a company based in Norway. And they sailed from Newfoundland in Canada all the way to Ireland, and they actually then sailed it up around the top coast of Scotland and over to Bergen in Norway. But once they'd hit this point, they were considered to have completed the race. Now this light pink one, called Open Transat, sailed last year and actually made it all the way to Ireland, but missed its target point that it had told us it was going to hit before it set off. And when it got to Ireland, they didn't manage to recover it, and no one's seen it since, apart from a bit of its sail washed up on a beach somewhere in northern France over here. So unfortunately that one doesn't count as having completed the competition. Now, we've built several big boats by this point and found that they weren't always the easiest things to handle. You often needed 3 people to get them in the water, and you needed a big boat to tow them around, which meant you needed a good whole day to work on them and good weather. And for doing some of the robotics experiments on how we deal with having robots out there for a long term, that actually meant it was quite slow to get any experiments done. So we built some smaller boats that we called the MOOPs, the Miniature Ocean Observation Platforms, and these are only 75 centimetres long. They're designed for one person to be able to handle them easily. You can fit several of them in the back of a car, and we built quite a few of these, so they're quite cheap to build as well. The whole deck comes off in one piece, so you've got access to everything inside. There's one big compartment, which meant it was quite easy to get your hands in and fix anything as well when anything goes wrong, whereas some of the others had compartments inside that made it quite hard to get to anywhere. And we built quite a few different types of these. Some had one sail, some had 2, most of them had wing sails still, a couple of them had fabric sails. We also tried one without a rudder on it, using the sails to steer instead. And the one you're seeing here in the video has 2 sails, which we found probably worked the best, because the sails can act to do some steering by setting them differently, but we can also use the rudder for steering as well, and that we found improved both the speed and the accuracy at which they could sail. Now, one problem with that design was it was quite slow, and we've been to quite a few international competitions where we sail boats on short distance courses. And we are not professional boat designers, we are computer scientists, and one of the people at one of these was a naval architect who knows how to design boats properly from the US Naval Academy. And he somewhat took pity on us for having designed this rather slow MOOP design, but liked some of its other features, like how small it was and how easy to transport. So he designed what's called the Maxi MOOP, which is a 1.3 metre hull based on very loosely the same ideas. And they've built quite a few of these, and we've built a couple as well, so they're used by the Abersailbot student sailing team, who you'll hear from later on. This blue one down here is one of the US Naval Academy's ones that they are testing in a swimming pool there, but they later launched into the Atlantic and tried to sail it in the Microtransat. And it went quite well until a fishing boat caught it, but they did, I think, 400 or 500 miles with a boat that's only 1.3 metres long. We then diverted into building motorboats after somebody from our geography department asked us if we could build them a boat to help survey a glacier in Greenland. So they took this boat we called Minty out to Greenland on a yacht that sailed from Aberystwyth, and you can see it there on the deck upside down, so that the silver front is a bit that's covered in steel to protect it from the ice, and the back is wooden, but that should get less exposed to the ice. And in the middle underneath there is a sonar to map what is going on the seabed underneath it and to the sides, and then on top it can take a 3D laser scanner to map what is happening above the water. And the plan is that it would sail along in front of the glacier where ice is constantly falling off, and it's quite dangerous for people to be there because some of these lumps of ice are very big and create large waves. And it would produce a 3-dimensional map of what was above and below the water, and then it would do it again a few days later, and they could work out how much ice had fallen off the glacier, because they don't really know how quickly the glacier is moving and how much ice it's losing. And it's obviously very dangerous for humans to make that kind of journey because some of these icebergs are very big. I'll just show you a bit of the video. This is the time lapse of the glacier, and you can see here these pools forming in the water are from bits of ice coming off. Now here we don't see any large pieces come off, but sometimes quite large chunks like this whole headland would come off and form giant icebergs that create very big waves and a big hazard for anyone trying to sail in front of it. Now we also took this boat we called Minty on a few missions in the UK. So here it is sailing on Bala Lake up in North Wales. We also took it to a couple of missions in Scotland and one down in Pembrokeshire to look at a shipwreck. So here we haven't got the laser scanner on it, we've just got the sonar, so it's doing a survey of the lake bed underneath it. And for this it has to sail up and down in a grid pattern, which actually takes a very, very long time, as you're just repeating the same bit a few meters separation each time you do it. And on board here we've also got two of these white sticks, a long-range Wi-Fi, so we can always be connected to the computers on it, and the white domes are GPS antennas that give us a very high accuracy GPS that lets us know where we are within a few centimetres. And this is the view from the camera that's on the front of the boat, and we get a live view back on shore of this, so we can make sure that there's nothing in our way. And here we were a bit concerned about this yacht that was sailing around us, that they might not keep out of our way enough. And we can always take remote control of it over the radio. And then back in our mission control, this is the screen we see with showing where the boat is, what its status is, and the video feed from it. And we also get the view from the sonar software showing us what that's currently seeing under the water. So we have a depth map here, which is colour highlighting the different depths of water. This up here is showing us how straight we're going, because it's quite important when you're doing surveys to go in a straight line. And we also need to know how much the boat's rolling and pitching, because the sonar needs to work out where, when it sends out a ping, that point is actually bouncing off. So if the boat's rolled over a little bit, that changes where that ping will hit on the seabed. And that's also why we need the very high accuracy GPS to work out where we were, and then we can work out exactly where it was that that ping bounced off. We then entered a competition run by the National Oceanography Centre to build a boat that was designed to go at very high speeds to a location and then sit there for a short while and or a long while, sorry, and do some measurements, such as doing some oceanography measurements, and then to drive back at quite high speed. So for this we built a hybrid boat that had both sails and a motor. And the idea with this one is that it could travel at up to a speed of about 6 knots under its motor and about 3 or 4 under the sails. And that it could also raise and lower the sails itself and raise and lower its keel, so it would bring the keel up when it was travelling under motor. And typically YouTube is not wanting to play this video for me. It is now starting to sail with a little bit of assistance from the motor, so it can always do both. And I'll show them the next video, and this is it motoring on its own with the sails down off Aberystwyth North Beach. Now the plan with this was, if we'd won the competition, which unfortunately we didn't, we would have built a much bigger version of it that would have had a diesel generator, solar panels and a wind turbine on it. So it could collect electricity from the wind and the sun, or it could turn on its diesel generator if it didn't have enough wind and sun to recharge its batteries, and the batteries would then run the motor, which would allow it to go at high speed. So if it spent, say, a couple of weeks on station just sailing around doing some measurements, it would hopefully gain enough electricity in that time to do a high-speed run back if it had run out of diesel already. So now we're not concentrating so much on building new boats, as we've got lots of boats, but instead we're looking at doing some computer vision and machine learning to pick up obstacles that these boats might see, because right now we haven't had any automatic obstacle avoidance on these boats, because it's been quite expensive, both in terms of the amount of electricity needed and the power of the computers needed to do this. But what we've started doing is training up a machine learning technique called a neural network, with lots and lots of example images taken from all the video we've got from our boats of what different obstacles at sea look like, and then we can use that to learn what we're seeing and just about be able to work out where they are and avoid them. Now this will also be coupled with data from radars or radio transponders. We won't just use the camera, because obviously it's not always good conditions to see, but that's just like the experience of a human sailor at sea. So now I'm going to pass over to Daria from Abersailbot to talk about the boats that the students have built and raced.
Welcome to the virtual Beach Lab. Today I'm going to talk about Aber Sailboat Society. We are a team of students building autonomous sailing robots, and our aim is to compete in the International Robotic Sailing Regatta and the World Robotic Sailing Championship. We have participated in various sailing robot competitions around the world, including World Robotic Sailing Championship 2019 in China, where we came second in our class. Our story has started in 2012, when a group of undergraduate students of our university decided to create a sailboat society in the town, which has one of the best seaside in the UK. We are using Raspberry Pi as the brain of our boats. This tiny cute computer runs a version of Debian and our own software to pilot our boats. We are using Python as the language for our software, and sometimes for some of our boats we're using custom designed open source hardware which is called Captain Morgan. Also, we're using Boat D for managing the control system of the boat. We have two main boats called David the Dragon and Kitty. So talking about David the Dragon, it's designed by Paul Miller, and Paul Miller is a former naval architect who used to work in a US Naval Academy and now for Coast Guard. He designed us a better version of our boat Moop and called it Maximoop. It is 1.2 meters long. In terms of performance, it aimed to 1.5 to 2 knots speed in typical conditions. It can be sailed in 90% of water in the world. The other 5% gets really high current, which makes it difficult to sail. It copes with waves really well and actually designed for crossing the Atlantic. It hasn't succeeded yet, but it could cross 700 miles. We're aiming to add a couple of sensors, such as salinity sensor, which calculates the amount of salt in the water, which is quite important parameter in terms of oceanographic research. And here is the video of David the Dragon. Coming to our second boat, Kitty. Kitty is a cat-rigged boat, which means that it has a single mast, steppable forward, and carrying a single sail behind the mast. This type of boat are also called cat boats. So what we are doing now? We have our sailboat experimental polystyrene boats competition, and this is for our new our sailboat members, which aims to introduce robotic sailing. Each team have to build a 1 meter long polystyrene boat with provided equipment such as electronics, materials for the sail, and the polystyrene hull, and of course a Raspberry Pi. Students are required to 3D print the rudder and sail drum, install operating system, the software, the servo, and vice versa. To keep our electronics dry, we're using a waterproof box which we put in the hole that we dig in the middle of the boat, as you can see in the photo. And those are the pictures of the boats that two groups of undergraduate students made this year. And here are some videos of one of the boats.
It's going upwind.
It's going upwind? I think it's meant to be taken about half an hour. Is that meant to?
No, that's good.
And it was our sailboat in a nutshell. Thank you for your attention and stay safe. Bye bye.
Okay, lovely. Thank you, Colin, ever so much for that. Fantastic presentation and lovely to see so many boats that you've got. So we're back with Colin Soze. And Colin, so how many boats have you actually got in your fleet?
Oh, I've lost count now. It must be at least 15, I think.
Wow, goodness me! It's wonderful to see a cross range of the small ones up to the very big ones. And I know over the years you've done lots of workshops with the children on different size boats, and it's wonderful to see it. Colin, we got loads of questions coming in on the live chat, and one of the things that did come up is water and batteries. Oh, they don't mix at all. So how do you manage to get over that? And what batteries do you use?
Well, we've used a mixture, and some of the bigger boats we've used just lead acid batteries like you'd find in your car. For some of the very small ones, we've used just AA rechargeable nickel metal hydrides, and for a few others, we've used lithium-ion batteries. But the rule with all of them is keep them away from the water. So where we can, we put them in the separate box. So there's a double hull between the outside of the water, the hull itself, and then the box that the batteries are inside.
Brilliant, really good. So another question that's come in from Patricia. How long did it take on the trans journey? How long does it normally take for some of the boats to sail across the Atlantic?
Well, the one who succeeded did it in 79 days from Canada to Ireland. That's probably a bit slower than what you could theoretically do with a boat like that, but they were not making the most optimal control of their sail. So you could probably do that route in maybe 40 days if you were really good. But for going the other way from Europe, it's a bit further, so you're probably looking at more like 80 days minimum to do that.
It obviously depends upon the wind and the currents,
yes,
etc., etc. And the wonderful thing about it is you've now got the technology to be able to track it as well, which is great. So another question that's come in, do you think that similar technology will be used in sailboats or very, very large boats for transporting people and goods?
It's starting to make its way in there, but it's been quite a slow evolution because obviously there's a lot of safety checks that we need to do before we can allow fully autonomous boats to be transporting people or even goods around. But I think it will happen one day, but we're not quite there yet.
And with a lot of the sonar scanning that you've been doing on the lakes, is another question that's come in. Have you actually found anything interesting in the lakes at all?
There was one scan I was doing, and I was really excited when I saw what looked like the hull of a battleship. And I thought, oh, I found this undiscovered wreck. Unfortunately, then looking on it with further detail, I realised it wasn't on the seabed. It was going next to me, and it was another boat passing alongside me. And the appearance on the sonar made it look like the hull of a much bigger boat.
Oh goodness, that must be frustrating. You see that one particular thing, your heart skips a beat, and you think, yes, we got something, and you think, oh no, it's something else. It's a bit frustrating there, but so the majority of the boats, they can navigate quite easily. You can see them in quite smooth conditions. But what about the big rough seas? Can they negotiate that easily?
Well, it's not easy, but it's got to be something they can do if they're going to sail like across the Atlantic. One of the attempts we had that went across the Atlantic had a wave monitoring device on board, and it measured the height of all the waves it went over. And the biggest wave it encountered was 12 meters tall. And when you bear in mind that the boat was just over 2 meters long, so that's 6 times the length of the boat. And actually on a good day, it was experiencing waves of 2 meters all the time.
That is really impressive. I mean, that's always capable of taking that sort of size wave. It really is quite phenomenal. It's really impressive. We've got a really interesting question which has come in from Robin. How long does it take on average between conception of a new boat design and from the boat sailing on the waves? How long does it take?
It varies from boat to boat, but I think probably the best example we've got that is Minty, the boat we took to Greenland. So we had that designed, I think, around about October, November of the year before we deployed it. And we had it in the water first in late April, and it was going off to Greenland by June. So that was about 9 months. And what was really nice with that was actually to see the evolution of it from a picture on screen, and then we actually printed out the plans on paper, then cut around those plans with bits of wood, and then started putting the bits of wood together in the lab. And seeing that come together from screen to paper to wood to a real boat that floated in a few months was a really nice experience to watch.
Isn't it wonderful to see the creation developing in front of you and how
you can make it and adapt it to be absolutely fit for purpose, which is.
And then I think when you start adding intelligence to it and it sort of comes to life, and for the first time you actually see it make a turn automatically. And the one I really love is when we're doing competitions, is seeing several boats in a row all make the turn at the same point. And there's something really magical there, thinking that all these boats were built by different people with totally different design strategies have all managed to achieve the same thing and actually sail themselves automatically around the same course.
Oh, it's fabulous. It's wonderful to see how the technology is being used, not only in land, but also on water. And obviously, I think in the future, you can also see how these boats, instead of RNLI guys having to jump into a lifeboat, you could potentially have a boat that would be capable of going out and rescuing people or personnel.
Well, that's already happening. There's rescue devices out there which are radio controlled that lifesavers are using around the coast, so they can drive a lifebuoy out to someone who's in trouble quickly.
That's fantastic.
Instead of having to paddle out there themselves.
Yeah, the way things are developing as far as the technology is concerned for the future, for so many things to help and save and support lives, it really is quite wonderful. Well, Colin, thank you ever so much. Really appreciate your presentation and your talks, and thank you ever so much. We hope we haven't thrown you too much for the Q&A, and so and thank you to everybody else who's sending in the Q&A for us as well. So good luck with that, and thank you ever so much for your presentation today.
Thank you.
Okay, so we're back live at Beach Lab 2020. We are supposed to be in this iconic building on Aberystwyth seafront today, but due to current conditions, we have actually had to change tack slightly, and so we are delivering online today. So although you physically can't see the robots, get your hands on them and be up nice and close to them, you can be actually close enough and see what the people are doing as far as the presentations are concerned. So we're going to move on now. So we've been on the water for a little bit, and now we're going to go into the hills, and we're going to move on to quite serious, big robots. I mean, I'm talking robots the size of a car and a Land Rover. I want to introduce you to Dr. Fred Labrosse, who is also another academic member of the Institute with us here in Aberystwyth University. And Fred's research interests focus on robotics and image processing, machine vision for robotics, specifically in the area of autonomous off-road navigation. So this includes autonomously driving on ill-defined roads. So you see the Google cars, etc., which are driving autonomously on the roads these days. Well, Fred has got the ones which can actually detect these things, but these are the sizes of Land Rovers. They're absolutely incredible. So there's real-time applications for these for archaeologists, biologists, and geographer. So Fred uses a variety of robots, ranging from large-wheeled robots to multicopters to fixed-wing airframes, and many of these robots are designed in the physics department, in the institute, and are now used for research purposes. So without further ado, we'll go over to Fred's presentation, and we'll be talking about autonomous driving in Welsh uplands.
This video shows an example of driving on tracks and off-road using a method we developed in 2017-2018. We specify in plain English a description of the route to follow using a set of keywords and numbers. The system only uses an omnidirectional camera for the navigation that can be seen at the top of the robot. The bottom right video is always an external view of the robot. The bottom left video is always the omnidirectional image captured by the robot. The top shows the result of the current processing. When driving on tracks, the top left video shows the front field of view from the robot, with shape showing where the track is detected. The top right shows how similar each pixel is to the color of the track. The color of the track is maintained and updated as we move along. The The shapes are fitted to the area that has a colour most similar to the track colour. The first instruction was to drive on the road for 15 meters at a speed of 0.5 meters per second. We can see that the road is clearly identified and that the sky has similar colour to the road. This is not an issue, as the road is looked for locally from where it was detected last time, guided by the similarity shown top right. When the robot is instructed to drive off-road, a relative heading is specified. The heading is tracked using two different methods. The first is what we call the visual compass, which keeps track of horizontal displacement of the pixels at the front and back of the robot and calculates the change in heading from that. The second method tracks a landmark on the horizon in the desired heading, or close to it. The robot steers to keep the two headings aligned with its front, which is where the white arrow is. The robot is now instructed to drive to a heading of -75 degrees to the left for 20 meters. Both headings are now aligned with the front of the robot, so it carries on straight. Now and then the landmark has to change, for example when it disappears from view like here, or has changed too much because of a change in viewpoint. The landmark is only a rectangular image that is tracked by finding the best pixel by pixel match. We now turn right by 90 degrees and drive for 35 meters. The visual compass and the landmark tracker don't always agree. We drive to the mean between the two. We turn right by 75 degrees and drive for 5 meters. Until we find a track and turn left onto it. We can now see a track, so we drive on it for 900 meters. We speed up the video as driving 900 meters at this speed takes a while. The difference in color between the track and its surroundings is not as clear as it was at the beginning, because there is a lot of grass on the track now. However, the track detection still works fine. The track suddenly becomes wider because of the intersection. The robot realigns itself with the center of the track. The track is now back to being grey without much grass on it, so the colour is quite different from the surroundings of the track. Changes in colour of the track are dealt with without any problems. Small localized changes are just ignored by the track detection method, while longer term changes lead to adapting the colour model of the road. The cattle grid is driven without fuss. The stony bank on the right has the same colour as the track. This leads to inconsistent detection seen as a red shape and triggers a reinitialization of the track detector. We arrive at an area where sheep are fed on the right. This leads to the entire ground in the area to be covered in mud and therefore being all the same colour, as will be visible in the top right view. So the robot centres itself on the wide area and aims directly for the feeder, and eventually is stopped by the laser-based obstacle detection system. for watching.
Absolutely fantastic. I absolutely love that robot. It is just so big and impressive. We're going live now across to Fred. So, afternoon, Fred. Hope you are well. How are you doing?
Yeah, fine. Thank you.
Good. Thank you ever so much for doing that and showing it. Really appreciate it. We have had quite a few questions that have come through on the live video feed on YouTube. And what's the longest journey that particular robot is capable of doing?
That's a good question. I think the longest it has done autonomously was 1.2 kilometers. The problem is that because we're not allowed to drive on proper roads, we're limited to tracks that we have access to. And usually these tracks are limited by gates and streams and things like that.
Brilliant.
So that's essentially what's limiting us.
And how heavy is that robot? It really is quite a beast, isn't it?
It's the one in the video we call Idris is about 400 kilos, probably a bit less than 400 kilos, depending on the equipment. The one that is just behind me here that we call Trevan is probably also similar to that, about 400 kilos.
And the difference between Idris and Trevan, which is the one which is behind you, what's the difference between the two, Fred?
The software systems are very similar. We drive them using the same sensors and all that. Mechanically, they are very different. Idris is a four-wheel drive, four-wheel steering, like a normal car, except that you can turn the front wheels and the back wheels. Trevan behind me is a skid steer vehicle, like a tank. So you make one side go faster than the other to turn.
Brilliant. We've had another question from Robin. Can the robot cope with unexpected objects on the track, such as livestock?
A very good question. That's very good. The system that is described in the video would cope without any problem if the obstacle was of a very different color from the track, because it would just say that it's not the track and therefore just turn away from it. The current version of the system, we also use height, not just color. And so even if the obstacle was the same color as the track, but obviously at a different height, because it's an obstacle, we would also turn away from it. We also have all the safety devices. So I mentioned laser-based safety obstacle detection that we use to detect when there's something in front of us, and then we react to that. We stop or we turn away.
Brilliant. Big, huge robots. Another question has come from Robin as well is, how does it cope with poor weather such as fog and rain?
So the test in the video, before that one, we've done a whole pile of tests all over in various places and during the winter. And so we've driven in snow, hail, horizontal rain, fog, etc., in the dark as well. And it's coped really well. The camera auto-adjusts to brightness, so even if it's really dark, it carries on. I mean, it needs a bit of light, but it carries on working in fairly dark conditions. And really the rain hasn't made any difference. The lens gets really dirty and covered in water, but it just carries on working.
Yeah, they are built for sort of extreme weather, aren't they? They are that robust, which is wonderful. We just had another question come in on the live feed chat. How fast can they go, Fred?
Idris in the video is limited by software to 10 kilometers per hour, about 6 miles per hour. Trevan, we've designed it to drive at 20 kilometers per hour. We haven't yet driven at that speed, so that's about 13 miles per hour. We haven't yet driven at that speed because it doesn't seem very fast, but it is scary when you have a machine like that drives on its own at that kind of speed. So we're waiting for the right conditions to test it at that speed.
So, I mean, that's one of the safety protocols which is built into the software as far as the robot is concerned, that it has those safety features that
if you need to remotely shut it down or stop it for some unknown reason, you know, another person, or there may be livestock or the environment and stuff that you need to say, right, I need to shut this robot down now, bang, it's capable of doing it, isn't it?
Yeah, we have all sorts of safety features at the software level, but also at hardware level. If any communication between bits of the robot doesn't happen, or between the laptop that we use to remotely instruct it doesn't happen, it stops. And if everything goes bad, then we have the big red button that we carry all the time with us that stops it immediately.
Brilliant. Well, thank you for that, Fred, ever so much. Really appreciate it. Absolutely brilliant. Love the video. Love the robots. They are just absolutely huge and lots of fun. And when we're all back, I'm looking forward to seeing these coming out on the field and having a good testing out again as well. So lovely. Thank you ever so much, Fred. Enjoy the rest of your day. And thank you for your contributions. Catch you later.
Bye.
So we're back on Beach Lab again, and thanks Fred for doing that. So we are now going to go across shortly to Rowan, who has been involved in doing a GCSE project. Now, obviously circumstances have changed where with school closures, etc., but Rowan is a Penglai student and has been involved with the robotics club for a number of years. A talented young lady whose building skills and programming skills have been able to inspire her to make some quite unusual projects and designs. So what we're really going to do is we're going to go over to the video that Rowan has already produced for us, and then as soon as that is finished, we're going to go on to a Q&A with Rowan. But once again, folks, if you're watching the videos and other bits and pieces and you got any questions about any of the projects that people have built, stick your answers onto the Q&A session live here, and then if you have any questions, we will actually ask it to the people as appropriate. So without further ado, that's enough of me. Let's go across to Rowan and see her next project.
Hi, I'm Rowan King and I'm part of the Aberystwyth Robotics Club. Now I'm going to be talking about my GCSE product design project. Unfortunately, the final product did not go towards the final grade due to unforeseen circumstances and school closing, but I decided to finish it anyway at home because it was a lot of fun to make. At the start of the project, I had no idea what I wanted to do and ended up doing a lot of sketching that I didn't need to do, and I changed my theme twice. I'm not the most decisive person. I knew I wanted to involve robotics and 3D printing, as well as wanting to do practical skills, and I don't think I could have made anything without LEDs. Eventually, I decided to make a hexagon cupboard that opens using servos at a push of a button. Originally, I was going to do it so the triangles opened up like an iris door, but I didn't have enough time to do all that, and the shape of the doors would have had to open in a specific way so they don't overlap and make everything strong enough to hold. I used plywood for the main parts and laser cut the back and cut the edges at an angle to create a hexagon shape. I also created shelf parts to go across the middle to make use of the space. The door parts on the front are made of Perspex pink transparent acrylic, which were laser cut into triangles. These were attached to the main cupboard by metal hinges that were glued on. Then I used 6 servos, one for each of the doors, attached a 3D printed arm and brackets to attach the doors so that they can slide up and down. 2 are longer than the rest because I forgot about the shelf bits, so I designed 4 shorter ones so that they wouldn't get caught. I used an Arduino which programmed the servos to open and close at a push of a button. Then I made a box to put the Arduino in, which I built to go on top so it can open up and I can access the electronics. I also added LEDs which are in different colours and turn on and off when the cupboard is opened and closed. I also 3D printed 6 glow-in-the-dark flowers which go in the front and are the same colours as the LEDs. They also draw attention away from the 3D printed arms and really stand out against the acrylic and the wood. I designed them on Design Spark. That was fun to do, except when the 3D printing filaments kept snapping, and I had to sit with the printer for half an hour each time to make sure it didn't run out and feed bits of filament in while it was printing. Thank you to everyone who's helped me build it, and the cupboard is now a great place for me to keep all my little 3D printed bits and bobs.
Hey, lovely, thank you, Rowan. I absolutely love that. Fabulous little cupboard. I mean, you've done incredibly well with that. So we're back with Rowan live through the wonders of technology. So nice to thank you ever so much for coming back, Rowan. And we've got scutters in the background there, which is great. We've also got a couple of feeds which have come in on on YouTube Live as well, so we'll be going to those shortly. But Rowan, a couple of questions that have come in already is how did you cut the box for the cupboard and the doors? How did you actually cut the box?
The main, like for the hexagon outside bits, my DT teacher cut it. I can't remember the name of the saw, but it was at an angle, and then we laser cut the back bit and the acrylic on the front.
Good. Okay, we've had a question from Fiona in one of the earlier videos that you did, and she's really inspired by the bits and pieces that you've done. You've learned so much, and so if you wanted to advise a beginner, what would be the best way to get into robotics as such?
I got into robotics through the robotics club, but I think just go online, look at different things, mess around with stuff, and yeah.
Okay. We've also got a live feed coming in as well, and it's wonderful. Some fabulous comments. You are inspirational. Absolutely brilliant. It's never about how many times a plan goes wrong. It's what you learn and how you keep on going. Now then there's one. Okay. With the programming, what did you use as your main control thing to open your doors?
Well, I used the Arduino, and we had 6 servos, so I programmed them to open at 90 degrees when a button's pressed.
And so there was a question from Glitterbomb. I know the Glitterbomb people. So what is the limit or range? So are there batteries on board, or how is it powered?
Well, we connected it to a socket, so it gets powered from the socket in the wall.
Okay. But if you needed to go on to battery power, so say for example, if you had a power cut and you had batteries on board, you got a battery backup system. So if you got something in your cupboard you needed to get out, you could override it like that, yeah?
Well, the servos, you can open them up by pulling the doors in if you need to, but I don't have a backup.
Brilliant.
Yet.
Brilliant. Well, Rowan, thank you ever so much. You are absolutely inspirational, and the live chat is exploding with loads of comments on your input and what you've currently made and what you're building. So in the future, one last question. What is your next build?
I haven't really decided yet, but I've got a lot of ideas for in the robotics club. I'm thinking about a Crichton head, and I need to do another project for my product design next year for A-level. So I'm thinking something a lot smaller and less likely to break, because there was one point building the cupboard that I thought one of the servos had gone, but then I tested it a few days ago and it turned out it worked. That's robotics. But yeah, I haven't quite decided yet, but I've got a lot of ideas.
Wonderful. On and up. It's fantastic. Thank you, Rowan, for all of your help and support, and it's lovely to see the wonderful projects that you're making and stuff. So thank you for that. We're going to go back now, and we're going to go for, oh, hang on, there we go. Right, we're going to come up with the rest of the program for this afternoon. We've got Rowan's younger brother, which is great,
taking part, and he's going to talk to us about Blender and robotics. And we've got another Andy as well, taking part in wireframe robotics. So that's what else is going on this afternoon as far as the next two presentations are concerned. And for the rest of the weeks, because it is Robotics Week, it isn't just about Beach Lab, it is about what else is happening within the Aberystwyth community and what is happening online. And so this week we have an evening of robotics, and so with the evening of robotics, it is in fact bio-inspired robotics. And it's an evening talk on discussions on bio-inspired robotics at Aberystwyth University. The key speakers for the evening will be Dr. Patricia Shaw, and her interests are in modelling of how children learn on a robotics platform. And Dr. Myra Wilson, and her interests are in swarm robotics and evolutionary artificial intelligence, particularly in modelling the behaviour of various insects for developing ad hoc communication systems. So it's going to be a bio-inspired robotics session, so that will in fact be on Monday night, and more details and the times and stuff will be available on the website here. On Wednesday, we have 3D CAD design workshop with Natalie, and so if there's anybody who's been inspired as to what they've been seeing here today, then you can have a look and follow us on that, and that will be able to give you an idea how to start on building your robots. On Thursday, we've got Thomas going on to an electronics workshop on how to build electronics to go into your robots. So as we said before, it may be a shoebox, but how do you get that shoebox to move? Okay, so there'll be the appropriate bits and pieces with Thomas as far as that is concerned. On Friday, we have an all family quiz, which you can come and join us in. It's going to be a bit of fun. It's a bit of a laugh, and if you're interested, then please log on to the website, and it will be able to tell you all about it and how to register for the competition. For those people as well who we've got youngsters and they're inspired, Dad, Mum, we want to build a robot, how do we do it? Well, if you go on to the robot crafts section of the website, then you can download workshops and kits and how to make the sort of family-friendly robots. So that's a bit of a schedule for what's going on. So now we're going to be, we should be at this iconic venue today. The sun has come out outside, but unfortunately we're stuck indoors. And so everything that we're doing for Beach Lab is actually online today. And so we're going to move on to another member of our robotics club. And in fact, this is Rowan's younger brother, Andrew. Andrew is very, very much into his CGI and his computing and creations as far as that is concerned. And so we're going to move on to a video which has been produced by Andrew, and then we're going to come to him later and do a live Q&A with him. So it's over to Andrew.
Today I'm talking about the relationship that film and digital effects have with real life robots. I mean, who wouldn't want to make the cool and sleek designs? Let's face it, they are mostly from visual artists, not engineers. This can make more creative challenges, of course, and they are sometimes reality checked, but I'm still waiting for someone to make a fully working, autonomous feeling Wally trash compactor. Okay, first off the bat, I want to talk to you about the magnificence of Blender. It is a 3D software that allows you to create, model, 3D print, do all of that good stuff, and also do CGI, which means computer generated imagery. Blender is a free package that includes two rendering engines. The first one is Cycles, which is a ray tracing engine which is slower, but it produces a lot better results. Eevee is a physically based real-time renderer that is a lot faster as it's real-time, but it produces worse results. I want to take a few seconds to explain why it's a free software. There's Blender Development Foundation and the creator of Blender admitted to not being interested in money. There's a long-running joke that no one admits to using Blender in the film industry, well, except from Barnstorm VFX, but we don't talk about them. Right, now we've got that out of the way, I want to talk about photorealism. Photorealism is creating an object or a scene in your chosen 3D software that looks like an actual photo. There's usually 4 steps to this. The first one is modelling, which is creating a object in 3D space that mimics a real life counterpart, like say a chair. Next is texturing, which is applying a material to your object that you already created. Next is lighting, which is mostly done by the software, but if done wrong then it can have disastrous consequences. Next is compositing, which is doing stuff like denoising, like when you have a render, it has these little particles which you can quickly get rid of, but I don't use the compositor much. Okay, but how about CGI and VFX in normal movies? It's usually best used when you don't notice it actually being used, like say a green screen with environments behind it. You just set up the green screen, have the people in front, key the green screen out, and then add in the environment behind it. There are actual people that's been made with VFX, such as the Blade Runner 2049 human. The team making this described as a technical and creative challenge. Okay, that's VFX in normal movies, but what about movies with robots? Because that's what we want. Okay, Star Wars, yeah, C-3PO is just Anthony Daniels in a suit. R2-D2 is just radio controlled and played by Kenny Baker, alternatively. BB-8 is usually keyed in with CGI, but there's 7 different physical BB-8s, and it's not really CGI. With Mouse Droid, it's just remote controlled. Okay, most iconic robots were made practically, but there's still that use in CGI in less universal but more technically impressive robots, like Transformers and Terminator, which have key aspects in the design of well-known robots like the Karate mech in China. This footage that you see now is part of a little tracking project that I didn't have time to finish before this, but I'll tell you how this works. Each point you see, the computer tries to keep that point in the same place on the footage as the footage moves around. This doesn't always work, and of course will sometimes veer off, so you need to set it back in the right location. Then you solve the points together and it tries its best to detect the motion and then generate a scene based on that, which you can add things to, and then it will move around with the camera. As I said earlier, I am making the mouse droid from Star Wars as well. I find it interesting to actually recreate the things that are a huge part of these massive productions, but in real life. The next random thing we need to create is an animatronic tortoise. Goodbye and thanks for listening.
Okay, lovely. Right, well, we're live with Andrew, which is great to see him. Hi, Andrew. Thank you ever so much for coming to join us. Andrew is another member of our robotics club, and looking at the end titles there, everything in that video was done by this young man. What a talent. Absolutely brilliant, and it's wonderful to see the way that things are, those skills that you're bringing to the table. Andrew, there's a couple of questions that the people are coming in with, if you wouldn't mind having a quick chat about it. The one with the chair and the additional bits and pieces on, how long did it take you to be able to create something like that?
Over 2 years. I mean, I was introduced to it in school. Well, I was introduced to Blender in school, but they just didn't do anything with that, and it just stopped immediately, and I was kind of disappointed, so I just looked at it by myself. Okay. And I've been on and on doing it for 2 years.
So brilliant, Andrew. So what other models would you like to make?
Mostly film stuff. I think that is a quite big thing to do in that with stuff like that.
Would you like to, in the future, I mean, there's a fantastic opportunity for budding entertainers and talented people like yourself for working in the film industry. Is that something that you'd like to do in the future?
Yeah, I would love to work in films, and I know so many people who like doing drama but don't like doing the technical aspects that I love doing. So yeah, and also creating small videos.
There's a little hidden talent there which is absolutely fabulous. As you know, we've got the 3D visualization system within work. I think when we come out of lockdown, I think there's a certain talent that needs to be enhanced and put onto that system to see what you can actually create, which would be great. Andrew, it's a question that's come in from Patricia, and it's great to see a different aspect to simulating robots. And what you've been able to do there really is very, very, very special indeed. So we're going to, what would you like to be able to create something in a virtual world and link it to an actual working robot so that they can communicate together?
Well, kind of like, I guess that 3D printing is kind of what you mean there. I mean, you can just export stuff from things like Blender into that type of thing, and that's kind of the relationship that happens between these type of things.
Your talent with blending really is quite superb. Love what you're doing with your CGI and your graphics. You've also incorporated the music there, Andrew.
Yes. It's kind of a side thing that I've been doing for about a year, and I'm just now coming back to Blender.
And
but yeah, it's been fun.
It's wonderful to see how you've mixed the music, the pictures, the graphics, and combined the whole lot together to produce something exciting like that.
Yeah, it's my theory that on the internet you can learn anything given enough time. So I've just there's about 4 things which I've been proficient in that I've learned completely by the internet.
Brilliant. So when we all do eventually meet back together, we're looking at taking it to the next level and see what you can actually produce. Yeah.
That'll be fun.
Yeah.
Looking forward to it.
Stuff. Well, thank you, Andrew, ever so much for taking part, showing us your amazing video, and taking part in today's Q&A session. Really appreciate it, and it's wonderful to see how much such fantastic talent that we've got as far as these youngsters are concerned. I mean, where are they going to go? This is what we do. We just like to touch paper and watch these wonderful rockets going off, and there's an incredible talent that we're going to be looking out for in the future. So thank you, Andrew. Have a brilliant day, and we look forward to seeing you again in the future as well.
Bye.
Okay, take care. Thank you. Okay, so we're back on Beach Lab, and the next section is we're going into Andy Forster. Now, Andy, another incredibly talented individual who came to Aberystwyth University through the Open University Avenue, and he's been with us for 2 or 3 years. Andy is an incredibly talented individual who has done his BSc and his Masters at Aberystwyth University in physics, and has been a fabulous supporter of the Robotics Club over the last 2 years. An incredibly talented individual who's gone down the pathway of doing a lot of CAD design, that is computer-aided design. And the 3D potential this guy has got really is quite remarkable, and it's wonderful to see the creation that he's made. We're hoping we're going to be able to get across to him live a little bit later on, and so at the moment we're going to go across to Andrew and have a look at his presentation and his videos.
Hi, I'm Andrew Forster, and this is my presentation for the piece of software I've been developing called Rigid Frame. It's a robotics control system, and it is used as a bridge between a physical robot and a person controlling it, or say another piece of software controlling it. It's essentially a system that works like controlling a puppet on strings. There are important areas on the puppet you want to move around, say the head or the ends of the legs. You would pull that string, it would lift it and move it about. And this is pretty much the same way this system works. It's still under development. There's a lot of things I want to do for it. It's written using the Unity game engine. So it's got built-in 3D supports, normally used for Class A games, and it's quite a nice system to work with. It uses the C# programming language, which for me is a bit like a mixture between C++ and Visual Basic. It's quite nice to use. So how does it work? Well, it uses a ball and stick framework system. So each point is connected between different sticks, which have got set lengths, and the software, the simulation, to call it that, is what's keeping those sticks to the right length, and that in turn keeps the whole framework, the rigid frame, sort of all in one, sort of all looking the right way. In the animation at the moment, it's only the two endpoints of the arm which are being influenced in that scene by the two circles. The larger circle is getting it to pull towards the smaller dot, and the smaller circle is actually repelling it from the dot. And all of this sort of working just pulls the whole arm round, pulls it down, lets it go. And what the software would be doing is looking at all the joints on that model and working out the angle. It would then send those angles to a physical robot, and the robot will be moving around, sort of mimicking it. That's the general premise of the robot. What I'll now talk about is 3 of the 4 robots that I've built so far. So the first of my robots is the servo walker. Essentially, I felt inspired one New Year's to use small SG90 servos. These are the low end of the scale of servos. They're a bit weak, but they're pretty cheap. You can get a pack of 10 for around 14 to 17 pounds. So they're quite useful. I designed and put together this little robot using Blender, and it worked out quite well to establish the system, the initial version of the software. So on the upper right you can see where I was initially developing it. I even built a small trailer to hold the battery packs, because as is usual for me, I get really excited when I'm building something for the first time, and I forget about including a whole load of things like any particular way of just holding the batteries or even any of the electronics. The upper left is kind of its final form. That's what I ended up with it in the end. Unfortunately, the weight of it became just a bit too much for the servos, but it was a nice exercise in getting things working. In the next slide is a sort of a short video of where I was testing some of the early sort of control interaction. So I'm actually using an Xbox controller here to cause it to tilt forwards and just generally move around. Something similar as, well, Boston Dynamics were doing this already with their little robot, and I was just sort of copying the style of it. So here's the Xbox controller, and yeah, I'm just using it to maneuver it. I do in a moment push the buttons to get it to lift individual feet, and this is where some of the flaws you start to see with the software, which in this case there's the first leg, yeah, it falls over. And that seems to be a common feature for all my robots at the moment, is the falling over bit. But all of this helped me sort of refine the software, getting the communication method working. It was using a Raspberry Pi Zero to do all the workings over Wi-Fi. And so the next robot is the Servosphere. This is where I wanted to experiment a bit more with the software and have different stances. So the legs would start folded in, and then it would deploy them and then move around. The next slide has a short animation which actually shows the legs deploying and the lid flipping up. This was done in Blender as well. I use it to create the components as well as the animations and the visualization. It's quite a useful piece of software. It also has 3D printing checks, utilities that it can do to make sure the pieces will be 3D printable. Here are some photos of what I ended up building. I have made some more modifications after this, but this is the initial stages. On the left-hand picture, you can see where I used small gear adjustments on the servos. So essentially, the servo, instead of pushing or trying to turn the leg itself, it was turning a smaller gear, which would then turn a larger gear. In this case, the teeth are faced inwards, just sort of inverted. That actually gave it enough strength so that it could keep itself off the floor. This is where I started to encounter a bit of issues with communication between the simulation and the robot. On the upper right, you can see for this case, I was using a Node MCU board, which is Arduino based but uses Wi-Fi. I did start to find some issues with the Wi-Fi, especially if I go somewhere different where I don't know any Wi-Fi passwords. It became an absolute pain to work with. This is the simulation. So again, I've updated the simulation with the model of this particular robot, and this is it's just a general walking sort of style. I use the arrow keys in this case just to move it along, and it works out its own lifting up and moving of the legs, but all it's doing is just moving the end points of each leg, and the rest of the frame is just distorting to follow it, and then the simulation measures the angles of each limb, sends it to the robot. A problem is that the simulation was running faster than the physical robot, and there was no checks to make sure the robot had moved into the right position. The next slide has a video where I'm essentially demonstrating this. So it starts up, which is sort of dips down, lifts up, and then I try getting it move forwards. As just happened there, it tried to lift a leg, but it hadn't balanced itself. It was just running too quick. And of course, as soon as it goes over too far, the servos can't cope. Yeah, it just struggles. So that one needed some upgrades, which I did end up doing. So as we can see here, I'm just going to show where I upgraded the top. I've got a small RF24 board, I think. So that's just a normal radio frequency. It's quite good. It's got lots of onboard libraries so that you can get it to easily connect to other aerials. That's Arduino Nano. Nice small form factor. It's a bit like a Uno in terms of power, but it's just smaller. Here's a reprint of the gears. I've done nice sharp gears, so they mesh a lot better. Those are done on the Ultimaker at the university. And that is the 16-channel PWM board. So I've fully maxed that out with 16 servos, 4 for each leg. That needs further calibration before I can continue testing with it. But like a lot of times, I get bored easily, and I moved on to my next robot. So this is the third robot. It was going to be using servos, and it was going to be an arm initially of 1 and then 2. So 1 would do the printing. This is going to be using a 3D printing pen or a printer head, 3D printer head, in order to print with. I got inspired by some sort of motors and linear actuators on Amazon, so I decided to switch from servos to linear actuators. And so in the next slide will be a short video of me testing the prototype. So what we had here is where the mouse is pointing now. That is an M4 bolt, and that is essentially moving a nut up and down. It's actually fixed into a gear. It's because the nut has a hex-shaped head. I can slot it into a large gear. An example on the left-hand side of the screen where the mouse is now. The 3-volt motor has its own gear, which turns the larger gear and then turns the thread, the bolt, and that moves a nut up and down. This extension piece, it just allows me to attach things to it, keep it shielded. This initial prototype, I changed the clip-on bits on the side so that they had an arm with a groove which held this in place, because one of the big problems is this entire piece will rattle as seen in the video, back and forth as it's operating, and this isn't too good. So we'll move to more details of the actual arm itself. On the upper right is what was initially wanted it to be with the 3D printing pen. I was going to access its electronics and then control it from there. Left-hand picture is the final model, using I think was a Sharpie pen as the sort of template model. And in the lower right is all the pieces in their little groups ready for 3D printing. Now here we have the 3D printed out model. I'm using potentiometers, rotary potentiometers for measuring the angle, and Arduino Mega with a LCD screen. I've actually modified a example script for putting information on the screen. So here I am using using the buttons to move the lower actuator to move the whole top of the arm. So this is still in development. I'm currently working on the motor control software side of it. So of course there's only one motor actually being controlled, so I've got to manually shift it across to a different motor at the moment, which is a bit difficult when you're holding a camera at the same time. So you see, I've shifted it so the end piece, that bit would be holding the actual pen itself. And that is the last of the 3 robots I've been making so far. Oh, sorry, yes, this is the 3D printing pens from Polaroid, and I've actually connected up 2 wires to the status LED. And that's the only thing I could manage to do because the solder for the buttons themselves were a bit too... They needed too high a heat, which my soldering iron couldn't reach. So at the moment, I'm just working on getting it to draw pictures, and then I'll move on to my 4th robot. So each robot so far has helped me develop the software a bit further. In this case, what it'll be doing is getting it to follow G-code, which is normally what's generated for 3D printing files, to get it to follow a path and just basically just do something with the environment. So it'll be that stage of setting up more involved control software. So this, on that note, it takes me to my final robot. When I initially drew up the little diagram for this, it was going to be using servos, but now I'm going to be using a mixture of both. So maybe servos for the articulation on the neck, for the beak, but it's going to mainly be linear actuators or modified, updated versions of them for the legs. On the diagram bottom left, I'm actually estimated about 19 servos overall at the time, with 7 per leg. And that's not taking into account the feet, because I want to have 2 claws, a little bit like raptor claws for those. But that's something I'd like to work on next, and that'll be a nice challenge because it'll be upgrading the server to work for 2 legs, making sure to improve the software, stabilizing it. And yeah, so that's where that one is going to go eventually. And with that, that brings me to the end of my presentation. Thank you very much. Any questions?
Brilliant. Well, that was great. Thank you ever so much, Andy. Lovely to see you. Looking great there. I love your background. Very, very futuristic. And welcome to Beach Lab. You're normally present with us. You have been for so many years, and really appreciate the help and support that you've given the Robotics Club over the last couple of years with the children and with the project. So great to see you, and thank you ever so much for joining us this afternoon.
Thank you for letting me do a presentation.
And another Blender enthusiast.
Yeah. Oh, yeah. I've been using it since about 2014.
So why Blender?
Well, it was free, really. That was the main starting point. Back in 2014, I was trying to go, actually trying to make my own game on the iPad, and I tried to go the route of doing 2D animation. And so I was drawing lots of characters, trying to do them each of the frames individually, and I sort of came across Blender, just browsing the net, and thought, well, I could try 3D and see how that would go, because I could design the model and then do all the animation sequencing on as needed, and it would just generate the frames for me, and then I just put them into the game as needed. But I got so, after many rewrites of the game itself, I reached the point where I thought, yes, the game engine works and I can play the game nicely, some sample levels, but it would take me another year or two to get the content developed. And at that point, I was running out of money, and so
the nice thing about Blender is it's shareware. It's free.
That's the good thing of it, yeah.
And the nice thing, you can see the wonderful creations that you've been making. And we go back to the last presenter with the other Andrew, and we see our youngest generation coming up with using Blender as well, which is fantastic. Andy, we have had a couple of questions on the live chat, which is wonderful. There's another one from Robin. So what is your process when it comes to deciding on how you want to start a project? What are you thinking about when you want to start a project?
It's a lot of it, like the very first robot I showed, that little this one. It came about because I found the servos on Amazon really cheap as I think a pack of 10, and I thought to myself, what can I build around that? So following the example of Boston Dynamics and their little dog robots, I thought I'll do that, and that came together. And from there, I've been drawing robots and anything like that for absolute years. So I've got a huge backlog of things to draw on. But there's also everything from anime with the giant mecha robots that they have stomping around landscapes to, I don't know, there's such a wide thing, I can't really think of anything.
Well, I know that Robin is saying as well on the live chat that him, as well as many of us, have been enjoying watching the progress of your 3D printing projects. It really is quite incredible. So Andy, what is your ultimate build? Where would you like to go?
It's something I think I've heard you remark that you'd like to build, and that's I would eventually want the software to reach to just essentially build a dragon, a fully capable. I mean, this is far into the future, but this is a fully flying, flapping wings robot.
Wow.
Maybe not breathing fire, but it'll be fun to do because there'll be the culmination of the software to be able to move through lots of different mediums, not just walking across the ground, but in a sense, in a way, like swimming through the air. So essentially, but yeah, I don't know. That's an end goal, but it's just to really get the software to be capable as a platform so that you could just plug it into a machine, tell it what the machine looks like, and then get some other software to sit on top to decide how it moves about, whether a person does it or AI. Don't know. But
something that is, I know, going to create that wow factor, isn't it? Isn't it just superb? And we're lucky that we've been able to develop the skills. The software is getting better. The 3D printing and the fabrication is getting better. Our only limitation is our own imagination, really, isn't it?
Well, I'd also like to thank Aberystwyth University and yourself for the opportunities to have somewhere to develop my robot. And if it wasn't for Dr. Dave Langstaff and his one of his modules on sensors and electronics that introduced me to the Arduino, I wouldn't really have reached this far.
Exactly. Yeah.
I've been stuck in a loop for many years.
Yeah. We've given you those life skills and those other bits and pieces to help you develop and move on. So, bit of a crossroads. Just graduated. And
should be getting my results hopefully near the start of July.
Good. Well, good luck with that. And I believe it's potentially looking for PhD positions as well shortly.
Yeah. I've been applying for various ones. I did apply for an agri robotics one, but they unfortunately turned me down on that one.
Oh well. Well, where one door's closed, other doors open, which is great. And I know a guy of your skills and your experience, it will go from strength to strength. So, Andy, it's such a shame that we can't be on the beach today, but you're here with us on in our virtual beach lab, and thank you ever so much for
helping us out and all the support you've given us over the last couple of years. Love your robots. Keep it going, mate. And we look forward to seeing your additional creations in the near future.
Yeah, hopefully there'll be many more. Thank you very much.
Good man. Okay, good. Take care. Cheers. Bye.
Goodbye.
Okay, so we're back here on Beach Lab, live literally. And so we've got the schedule coming up for the next lot. So we've gone from fighting robots through to sailing robots to land robots. But what about pet robots? What about robots that will support people in a comfort way, where people will want to, like the youngsters, children, they can learn from looking at different things and interpret things in their own way, through across to the elderly who may want to have some sort of comfort robot, something that'll act as a companion. The way robotics and stuff are developing now over the last 10-15 years, this could come in a way quite dramatically in the next couple of years, especially with the advancing of sensors and artificial intelligence. So we got two sessions coming up, one with robotic pets with Thomas, and another one with Myra with Patricia. But before we go on to that, just a little reminder of what is actually happening again this week. We've got an evening with robotics with Patricia Shaw and Myra Wilson. On Wednesday, we have 3D CAD design workshops with Natalie Roberts. And so if you want to build robots, then this is the ideal platform where to start. You want to make your robot move, so basic electronics and bits and pieces with Thomas Fern on Thursday. On Friday, we've got a pub quiz for all the family. It's a bit of fun for everybody to join in. And so if you want to be involved with us, then please do get involved and joining with Robotics Week. And obviously, finally, as well, for all week, anybody that you've got young children or you want to spend a bit of time crafting or something like that, we also have robotic crafts, and that is available through Robotics Week. And if there's anything that you need to know, then obviously then you can pick up the bits and pieces from this URL, and information on Aberystwyth Robotics Club is through aberrobotics.club. I've been up this 5 hours. It's getting long, but we've got a couple more to go. So without further ado, I need to now introduce our next presenter. I'm going to quite enjoy this one because it's like a chip off the old block. Thomas is a very talented individual. And he's been interested in robotics ever since he's been quite a small boy. He's always been involved with the robotics club. He ended up with a first-class honours degree in computer science and has moved on to doing a PhD in autonomous wheelchair in dynamics environments, and is also a member of the Intelligent Robotics Club. It's amazing to see what he's already been able to make, what he's been involved in doing, and the stuff that he's created and prepared ready for getting the whole of this machine running today. I'm biased because he's my son. So thank you for that. So if there are any other questions regarding the pet robotics, then please pop them onto the Q&A on the live chat, and then we will ask Thomas some questions at the end. So it's over to Thomas. Here we go.
Hello everyone, my name is Thomas Fern and I'm a second year PhD student in the computer science department, and I'm going to talk to you a bit about Cosmo, which is this little fella right here. It's a little robot, but there's a lot which comes with this little package. So, what is Cosmo? How does it work? what is inside it and what makes it such a great robot for being such a small robot. So, what is Cosmo? Well, Cosmo is actually a children's toy, at least that's what it's advertised as. The reason for this is it's in that sort of price range where it's commercially acceptable to buy one for a very lucky child. It's very robust considering its size, but the thing which makes it a children's toy is the way it works and the way it interacts with the environment. So, where can you get one? Well, it's a commercial chassis, so you can buy them from any main retailer once we're out of lockdown. They cost roughly £175, which is quite a lot for a toy. But if you compare it to a more research grade robot, then it's significantly cheaper. So, without further ado, I'll show you some demos of it working. Here's a video of Cosmo using its onboard camera to follow a person's face. And here's another video of it using its awareness of its surroundings, being able to detect several cubes with different patterns on them and stacking one cube on top of the other.
So, first story is, you know, your laptop wasn't pulled directly to that, you are going to have to put it on the other network. It's zero now. Just try it and we'll see what happens. It's zero. We may have to go with a different alternative for you guys to have to zero. Zero. It's zero.
So, as I said, Cosmo is in fact a child's toy. Now, it comes with a very, very good Android and iOS application. So the aim of the app is to be as intuitive as possible for any age group. So in the app you can play with it, you can play all sorts of games. It does in fact have a block-based user interface for being able to program it, so people familiar with Scratch would be away with that straight away. And you can also feed it, which is unusual, but that's what makes it such a pet-like character. So, how does it work? Well, there's a little bit of magic going on, and not everything is as it seems. So we've been saying that the robot can do this and can do that, but you can't really fit a powerful computer into something so small. So it utilizes the onboard computer inside this, takes in all the readings from the sensors like the camera and the encoders, which allow you to work out how far it's moved, as well as other sensors to make it prevent falling off a table. So the app does a lot of the decision making for the robot, but the robot executes all the instructions. So it does have a lot of other features as well if you start digging into the software behind it, if you're keen on programming. So you can connect it with other third-party libraries. You can ask the Google Assistant to instruct it what to do. Because of its onboard camera, you can also post photos to Instagram, as well as being able to publish tweets as well. So you can find out what the status of the robot is that way. And as I mentioned before, because you've got access to the camera on board Cosmo, you can perform a lot of research-based tasks, mainly including machine vision, so you can get it to recognise people's faces as well as lots of other household objects. So, what's inside Cosmo? The way it drives is that there is 2 motors in the robot, there's one on each side. The way it travels around and understands where it is it has lots of sensors in the wheels, so it can understand how far it's moved and how far it's turned and at what speed. And we've got tracks underneath the wheels that gives it quite a lot of grip to be able to climb over a variation of different surfaces. What makes it such a brilliant toy is the emotion that it can display. Now, when you have this in play mode, then you can have it change its own emotions and moods, and to do that it uses the LCD screen on the front here, so it looks a bit like a pair of googly eyes, but it really is a great interactive tool, and that's basically what it's made it so popular with children. So as far as the camera, there is just on the front there was a very small camera, and what that does is it streams back into the application on your phone or your tablet, and that does a lot of the processing for it. As far as intelligence, as I said, there's a bit of magic stuff going on, but being able to recognize and interact with objects makes it such a great toy to play with, and you can really do a lot with it. You can build your own games, you can get it to recognize all sorts of different patterns that you can draw out. It also learns from its mistakes, so there's a lot of artificial intelligence which goes into this little robot. So as you saw with the videos where it didn't quite pick up the cube the first time round, it knew exactly how to correct itself for the second and third time. It also behaves based on its decisions and its moods as well. So if you found that it has lost a game, it will go into a bit of a sulk, like a bit of a spoilt child, but that's what makes it so cute. So it really does develop its own personality in that sense. So, what makes Cosmo a great robot to have? So, apart from its cheap-ish price tag, you get a lot for your money. At £175, you have got a robot which you can program in 2 very popular programming languages, Python and C++. Most people have got a smartphone or tablet that they can use to work with it, so you don't need any extra kit to go alongside it. It's jam-packed full of sensors, and you can really do a lot of sensing around the environment with it, which makes it a really excellent flexible platform for developing research, whether it's in education or how robots interact with people. But yes, it's an awesome little robot. So thank you for listening, and any questions?
Okay, well, thank you ever so much, Thomas. Great. Oh, we're talking about a live feed. We've literally got a live feed where today we have in fact been going through the various Zoom technologies to be able to link up with people and bringing people live onto the chat. We have changed things slightly, so I'm going to move up and move Thomas in.
Hello.
And yeah, so welcome, Thomas.
Thanks for having me.
That's all right.
you've been driving everything all day, so
I've been pressing buttons.
yeah, fair play to you. It's been fantastic. So, yeah, there has been quite a few questions which have come in on the live video chat. I think you need to come in a little bit more. We don't want half of you. We want to see all.
Oh,
of
you need to shuffle your chair
Okay,
over a bit.
yeah, sorry. Right, okay, here we go. So, lovely to see Charlotte is supporting us and watching us from down in South Wales, and one of the ex-presidents of the undergraduate club, which is great to see her. So thank you for joining us, Charlotte. We've had a question from Patricia. It's such a sweet little robot, but can still do so much. And how does it, Thomas, then be able to stack cubes?
It's a very good question. I've actually got Cosmo with me at the moment. So, where's the camera? There it is. So, as I said, it is jam-packed full of sensors, and because it has such a good idea of what's happening around the robot, it can create a map. So, we've got 3 of these little cubes dotted around the robot, and it uses these as markers as to where it thinks the robot is in the world. Now, each cube has a different pattern on it, so it can identify individual cubes. So this comes basically out of the box, and it recognises them already. So it hunts for one pattern, and as soon as it finds it, it drives over to the cube, picks it up, and then it goes round and it searches for the second pattern, or the second cube, and then it'll align itself up to the little holes on the side of the cube, and it works.
Good, marvellous, fabulous. I don't know what they've managed to do to stick all of that information in this little machine. It's phenomenal.
Well, that's a little bit of the trickery.
You know,
a lot of the processing doesn't actually get done by the robot itself. A lot of the decision making is done in the application on the phone and tablet. So all the robot does is take information and execute instructions.
Okay, and we've got another question from Patricia. And does the robot get moody if you don't feed it?
Yes.
Moody robot?
As I said, with robotic pets, pets can get grumpy. This one has incredible temper tantrums. It'll bring it back. It's got a little arm on the top, which it can bring up and down. When it gets grumpy, it'll bang its arm on the table to try and get some attention. It'll also get quite erratic as it changes its moods. It can get very excitable when it's had some food, or you've been playing with it, or if it's lost a game, then it'll get quite grumpy and it'll start thumping its little arm around the table.
Okay, another question has come up on the live chat feed. Can you teach it to recognise other patterns and do things in response to those?
Yes, the application itself is only restricted to using those 3 cubes. But as I said, with the software development kit that comes free with the robot, you can use other libraries like OpenCV to teach the AI which different patterns exist in the environment, and you can then execute different instructions or tasks for Cosmo to do based on those patterns.
So is there another upgrade as far as this robot is concerned?
Yes, there is a second iteration of Cosmo. It's known as Vector. It's a lot more expensive, but it's based on the Alexa sort of smart home assistant. So you can say, Vector, play something on Spotify, and it'll go and do that for you. It makes it a lot more interactive, but it significantly reduces the battery life that's on the robot.
Isn't it wonderful that you can do such a multimedia centre literally off a small robot like that? And you know, if they're producing things like this now, what are they going to be like in sort of 10 years time? And so Question from Charlotte: can you fist bump him? So
yes, as part of the app and the sort of interactive sort of playing mode that it has, you can unlock features and fist bumping and different hand actions it can recognise and copy.
So there you are. There's a certain, a little bit of an introduction into part of what can be done as far as pet robots are concerned. And when you can produce something like that, what are other things that are going to be done in the future? So a huge thanks to Thomas for that.
Thanks for having me.
That's all right. Please do come back. You're more than welcome.
I'm just going to move a little bit to stage left.
Don't go too far, because we may need you. Okay, will we ever make a double act? I really don't know. So thanks to Thomas for that. There's a lot of work and preparation gone into today's effort and behind the scenes. And he's just said to me before he did his presentation, I was actually doing that presentation at 3 o'clock this morning. So as you can imagine, we've both been burning the midnight oil a wee bit to get everything ready and ready for today's presentation. So we're now going to move on to the next part of sort of pet robotics, and we're going to go across to Patricia. And so have you, as an individual, have you ever fancied having a robotic pet? And so Patricia is going to explain the background behind a robotic pet called Myro, which is also commercially available. So thanks for that, and we'll go across to Patricia.
Hello again. Hope you're enjoying today's talks as much as I am. I'm back again to this time talk about Myro. Now, if you visited Beach Lab previously, then it's quite likely that you will have come across Myro in previous years, and you'll know just what Myro particularly likes from people that come to visit, and that is stroking. Myro is possibly the most emotional, demanding robot that I've ever actually worked with. And that one of the reasons for that is that Myro is a biomimetic robot. And what that means is essentially that they've tried to model animals, model animal behaviour, model the way that the animals actually think in a robotic platform as much as possible to reproduce many of the behaviours that we see in pets. Specifically, sort of your pets like dogs, cats, rabbits, that like to be stroked, they like the attention, and they also get scared quite easily. And Myro particularly gets scared when there's ever anything noisy. And if you recall, Beach Lab can get pretty noisy. So the only way to keep Myro calm during those days is literally to stroke him all day long. And he loves to be stroked. So a very friendly robot. But this year, as we're not actually able to be there in person, I thought I might actually try and show you some of the different sides of Myro, introduce some of the different features that perhaps aren't always easy to show in such a noisy environment when all he wants to be done, all he wants is stroking all day long. So before I go into those, I thought I'd introduce Myro, show some clips of Myro in a more natural setting, and then go through some of the different features of the robot. The very first thing you'll notice about Myro is these lovely big ears. As the wolf says, big ears are all the best for hearing with, and literally these are ears. They're able to rotate. If I get this, hopefully you can see. Where? There we go. We can actually see it. Yeah, yes, Myro. They can actually rotate the ears independently, and able to use that to be able to track sounds down quite reliably. We also see we've got two quite large eyes, and the eye, while the eyes themselves can't actually move, it does have eyelids that you can blink with, and you'll notice it's sort of slightly spaced out. So it gets like a rabbit that actually sees slightly outwards to be able to get a wider view around him. In the nose, I lift up the nose slightly, you might be able to see a couple of sensors hidden in there, and they're ultrasound sensors which can be used to detect distance to objects. And shall show you that working. Moving on to the back, we have a lovely tail at the back, and if I can wag the tail slightly, we can actually see that moving. And when Myra's happy, the tail most definitely wags. And you might be able to see the lights there gradually changing, indicating the mood. And Myra is currently neutral. It's not too happy, not too sad, but willing to be played with a little bit. So what I'd like to quickly do is show you some videos about Myra. Now, what I'm going to take the opportunity to do now is actually show you some of the side of Myra that you wouldn't normally get to see, and that's actually reading the sensors and looking at some of the behaviours in a bit more detail. So what we can see here is the sensor readings from Myra. So we can see the two cameras looking at the camera at the moment. You can see the images from both eyes, and as I say, they're slightly offset, so there's not a huge amount of overlap. We can also see the touch sensors, and as I stroke Myra, we can see those changing. Or as I stroke the head, we can start to see the head sensors changing as well. A little bit there, it likes to be scratched behind the ear, slightly. We have light sensors around the base of the robot that are able to detect how light or dark it is, and we can use a sonar to see how far away an obstacle is at any point in time. The cliff sensors will hopefully help it stop it from falling off the table, but at the moment it's quite nice and secure on the table. And then there's various other sensors that we can see that tell us a bit more about what's going on inside the robot, what the robot is currently sensing in terms of motion. We have the ability to manually drive the robot around. That was what I was just using a moment ago to be able to control the robot. So we also have the ability to see the microphones, and as I click, we should be able to see Myra moving towards those sounds. There we go. So what I'm going to show you next is to do with the motion side of the robot, which is where Myra starts to get particularly sensitive about things. So at the moment, we can see the state of the robot. And what mood it's currently actually in. Now let's put it into a neutral mode, just to stabilize things. And you can see the emotional state is being reset to neutral, 100% neutral. Now, in this state, what we might be able to see is the lights are generally white, slight yellow. Not too happy at the moment because I'm picking them up. But it's relatively gradual changing, and especially as we change to relax, it's even more slow and gradual and it's changing. When it's changed to neutral aroused, then we can see it's a bit more proactive in terms of the movement that it's making. The lights are flashing a bit faster, but we can change it to other modes as well. So I'm going to set it to unhappy neutral, and what we see straight away is that the lights change to red. So we've got red lights showing the unhappy state, but they're sort of not too proactive. In relaxed mode, it's much more gradual change. There's no sudden movement, but it's definitely not particularly happy at the moment. If, however, we change it to the unhappy aroused, then we get quite a sudden change in behaviour. The flashing is much faster, the vocalisation changes slightly, a bit more urgent if you like, and the movement is normally a bit more erratic than this, but I think at the moment he's perhaps getting a bit tired and it's been a long day for him. So if we change to happy relax, then there's an obvious change in behaviour. We go to green lights, much happier, and generally relaxed movements, normally relaxed movements. At the other extreme, we change to happy aroused, then it's actually quite interested, it's wanting to play with us and showing more interest in what's going on around it. Normally. But robots never behave for live demos, so I'm going to change back to neutral there for the moment. Now, there's one last trick that Myra doesn't normally tell anybody about. Got that. Myra's got a secret ability. He very rarely tells anybody about his secret ability. But just for you today, he's going to show it off. So, are you going to show me your secret ability, Myra? Take it away.
Yarr! Ahoy, matey! Yarr, walk the plank! Yarr! 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 Yeah! Yarr! Yarr! Shiver me timbers! Ahoy, matey! Yarr! Yarr! Shiver me timbers!
Who would have thought that Myra was secretly a pirate? Thank you, Myra. So there's Myra. So the question is, what is a robot like Myra really useful for? And what are we doing with Myra? Generally, Myra is designed as a pet, a social companion, a robot to keep you company at home during the day. You can see it's a friend, it's a social creature, it has emotions, it wants attention, possibly too much attention at times, but it's there as a friend, a companion robot. It's also been developed more recently as an educational robot, so they're making functionality available to be able to program the robot a lot more. So you might actually start to see Miro appearing in some schools across the country as they expand the programme further. One of the things that we've been quite keen to investigate with Miro is whether Miro could actually provide more than just a companion in the home, but actually provide some service as well. So especially for elderly, those living alone, those that are perhaps a bit more vulnerable, whether Miro could actually provide a alarm system if something happens, goes wrong, or if the person needs a bit of a help. Now, clearly, Miro doesn't have any arms, doesn't have the ability to speak and avoid, sort of explain issues particularly clearly, but could potentially detect if somebody has fallen over. Could potentially detect if somebody's had an accident, if they've fallen over, and raise an alarm. It's internet enabled, so it could potentially send out a message to some preferred contacts in order to say, my companion has fallen over, had an accident. But it could also actually help if perhaps you're having a bad day. So let's say you've not got up at the normal time, you're struggling to get going, then Miro could actually be able to come in, say, recognise the fact that you're breaking from your normal routine, and potentially encourage you to follow some kind of activity and routine. So we've been looking at sort of games that people could play with a robot such as this. The most obvious ones are sort of fetch games or follow games. We've also looked at some action games where Miro perhaps calls out in its own voice a particular shape. You have to produce a shape or show the shape. But you can also use the cameras to recognise body poses, so could encourage exercises, for example. So there is potential for, as a companion around the house, to not just be there to keep you company, but could actually serve a purpose there as well. The other option that we've been exploring for Miro is as an educational robot for those with perhaps learning difficulties. Now, as a robot modelled on an animal, it shares various similarities, properties with animals. And for those perhaps on more on the autistic spectrum who struggle to understand the emotions displayed by animals, then Miro could actually provide a platform for learning how to interact safely with an animal. If you poke an animal in the wrong way, if you don't take care of it, then it makes it unhappy. And sometimes that's not always very clear from the animal's behaviour. But when the lights on Miro change colour, then that's something that's very easy to identify, very easy to pick up, and can be used to say that's a behaviour that isn't very enjoyable at the moment, it's making me unhappy. Whereas more of a stroking type behaviour obviously makes Miro very happy, but is quite clearly visible in the change in behaviour from Miro and the change in the colour of lights. And that's certainly an area where children, perhaps on the autistic spectrum, who struggle to read those emotions from animals, can very quickly see the change in behaviour on Miro. And then you can start to try and transfer that behaviour from the robot to the real animals. So those are various applications that a robot such as this could be used for. Or we could just actually sit here and relax and stroke the robot all day, which can in itself be quite a therapeutic activity when you get stressed. So I hope you found that informative and interesting. And I hope you enjoy the rest of the day.
Okay, oh, fabulous. Thank you ever so much, Patricia. That was absolutely wonderful. It's amazing what these robots can actually potentially do now and help and service people in the home environment. And I can see one of the uses for Miro to, say, for example, now people who need a regular reminder to take their medication, that as a service dog, it will interact and remind you to take take your medication. So this is our last live Q&A session. And so we have got a couple of questions that have come through on the live chat. One of the ones that noticed was Andy was saying the noises it makes reminds him of Pingu, which is quite unusual. And there's a question is coming from Helen, which is quite interesting. Do you know what Miro is saying? And do the sensor readings affect the sound it makes?
So, yes. Well, I don't know what it sounds like to me, except perhaps that one. Certainly when the change in sensor readings does change the behaviour. If you pick up Miro really does not like to be picked up. And so we'll actually start to make noises about that. When Miro gets stuck anywhere, it'll also make noises, say it's stuck and needs help. When batteries are running low, it will have a little alarm there that goes off. But it's interesting about the sound that the Miro does make, because when they were developing the robot, I'm not quite sure how far they went with it, but they certainly looked at trying to adjust sort of the sound of a dog barking for the scale of the animal, and to see whether they could produce something like a dog barking for the scale of Miro. But no, I think they've gone for a slightly different set of voices, if you like, the real robot.
Talking about sort of interacting, what was really unusual is that you had Miro sitting next to your dog, which was great. So there's a live dog didn't really mind having a robotic dog next to it. I know that in our instance, when our golden retriever sits next to K9, all hell breaks loose. But what was interesting is with the technology that we got here, we got a live chat going through to Rowan and Andrew's house. And as Miro was making the noises, we noticed that Sky had her ears pricked up listening to what was going on. So it looks like there's some sort of interaction there that the real dogs actually are picking up on the noises as well, which is wonderful.
Yeah, they certainly seem to react to each other, but I think thankfully our pets have got used to robots running around.
Brilliant. Usual question again is, how fast does it go? It can't keep up with a greyhound, but it could beat a chihuahua.
I don't know whether it could go as fast as a chihuahua, possibly. Certainly it can spin quite fast on the spot, but generally it's not something I would need to worry about not being able to outrun.
There was some interesting comments on the live chat. I think you ought to rename it from Fiona, and she says, can we call it Captain Jack Miro? And there's also an addition on that as well, which is a nice little twist from Helen. And can we make Miro a little pirate helmet, a pirate hat, I should say, a nice little peak with his ears sticking out through the top. I think that'd be a lot of fun, wouldn't it? Captain Jack Miro.
That'll certainly be a nice craft project for somebody.
Yeah, but it's a lot of fun. But it also has a lot of serious implications because learning, monitoring, helping people as a service dog. And you can see how Boston Dynamics have now produced incredible robotics to be able to interact with people and be stable within an industrial environment. And it's something that will, I think, at some stage, something cute, fluffy, etc., will come into this environment to help. And you can see how Alexa is working and Google is working now. You can see how this will come into its own as well, won't it?
Definitely. Robots around the house are increasingly becoming more common. And of course, the Internet of Things means that they're all connected to each other and so can actually provide assistance as well, not just as companion.
Do you find it difficult to learn obviously you're a computer scientist, you know these programming languages and stuff. Is it difficult to program the Miro?
So it's not quite as simple as a block-based programming language. It uses something called the robot operating system, which provides a lot of the underlying infrastructure to be able to provide some basic behavior. And then on top of that, you can program it in either Python or C++. Python's quite a straightforward language for people to get started with. C++ a bit more in depth, but has some nice functionality.
Brilliant. Well, thank you, Patricia, ever so much. And thanks to Myro. Did a fabulous job. There were no leaks on the carpet, which was great. And the nice thing about him, you don't have to take him for a walk.
Yep. Very much prefers to stay indoors. Is not an outdoor robot, this one.
Indeed, indeed. And it's the way things are going with technology, with robotics, you know, with what we've seen within the last 10 years and where the things are going now, then hopefully it's there to support us and not sort of take over us, which is great. So thanks for that, Patricia. Thank you ever so much for all your help and support today.
Thank you for such a brilliant day.
Yeah, we'll look forward to seeing Myro again in the future. Okay, so we're on to the last part of what's happening for the rest of this week. Problems with these glasses today. So we have on Monday night, we've got evening with... I must be getting tired. Monday night, we've got an evening of robotics. It's a Q&A session on robotics, and if you're interested in finding out about and registering for that particular session, then if you go to the link below, you can actually register yourself with it. It is a bio-inspired robotics evening, talks and discussions, discussing the latest research bio-inspired robotics at Aberystwyth University, and you've got your opportunity to answer questions from the key speakers, who are Dr. Patricia Shaw, who you've seen quite a bit of today. Patricia's interests are obviously in modelling how children learn on a robotics platform, and in particular constructing longitudinal models of learning and investigating how play can be used as a mechanism for discovering knowledge. That's Patricia. And our other panellist for Monday night is going to be Dr. Myra Wilson from the same department. And Myra's interests are in swarm robotics, evolutionary AI techniques, and in particular modelling the behaviour of various insects for developing ad hoc network communications. So that's our Monday evening of robotics. Okay. On Wednesday, we have a CAD design workshop that will be with Tally. So if you want to make your own robot, you don't know how to, and you fancy doing a little bit of CAD, then if you go through with Tally, and she'll show you how to do that. On Thursday night, we've got electronics workshop with Thomas, basic electronic circuits, and how to make things to get things running, etc., etc. All the robots that you've seen today require some sort of power. So there'll be some stuff with Thomas. On Friday night, there will be a fun night. So no Q's and A's, no robotics on show, but it will be a robotics pub quiz. It's a family environment, so anybody can come and join in and have some fun with us. And for during the week, if anybody does have and wants to build up their own robot, people who are still in lockdown, younger kids who fancy building a model robot, then Tally has produced a robotics crafts sheet where you can sort of make your own robots. All the information as such is available on the Robotics Week website, which is available here, and more information on the club and some of the activities that are involved with the club is available at aberrobotics.club. So that's the lineup, that's the schedule for this coming week as far as Robotics Week is concerned. A huge thank you to everybody that has taken part in today's proceedings. It's been a lot of work to try and get these bits and pieces together. That's the way it goes. Circumstances are slightly different. We should have been at the bandstand where we have Daleks and fighting robots and other bits and pieces promenading. We couldn't make it, so we've done it online today. We will be back next year, hopefully back at the bandstand. We've got each year getting bigger and bigger and bigger with bigger and more attractions. We are certainly hoping that Razor, the Fighting Robot Wars robot, will be with us next year, so you'll be able to actually come and see him in real life instead of on television. My huge thanks to Thomas for all the tech and stuff and bits and pieces behind it. Really appreciate it. We couldn't have done it without you. Our huge thanks to all our helpers who have been involved as far as the committee is concerned in bringing this to life. A huge thanks to all the contributors who have done videos, from old guys like me to the younger guys in the robotics club. Really appreciate it, and it gives you an idea of, you can see what sort of talent is coming up and through the system. Absolutely fabulous. If I've forgotten anybody, my humble apologies. Thanks to everybody who's been coming back and forwards to us on the live chat with all your questions. I love what some of the weird, wonderful and wacky questions that have come up. It's been absolutely brilliant. Thank you for the live feedback. We've had no technical hitches, but as with everything else, it's all in the preparation. So thank you ever so much. We look forward to seeing you again in the near future, and have a great weekend.